Yeah, good evening to everyone. I am Dr. Avinash SS, one of the mentor at Study Medic Study MRCOG group. Welcome to this LRR marathon schedule series. The last module is on the topic biostatistics. In today's topic, we will be briefly discussing the basics of the biostatistics as well, trying to solve some of the questions and trying to see how we can solve the questions in the exam. Okay, so we will be discussing very briefly, since it's a part 2, we'll be discussing briefly on variables, and also briefly we will have an overlook on measures of central tendency, that is mean, median, mode, etc., and the characteristics of the normal distribution curve, and how to calculate the confidence interval, what is the standard error of mean, and then we'll have a detailed look on hypothesis testing, p-value, types of errors, and power, and also which inferential tests to choose and when. And then we'll have a detailed look on the different epidemiological study designs, how to calculate different diagnostic accuracy tests like sensitivity, etc., and the effect estimates like odds ratio, risk ratio, etc. So this is all what we are trying to cover in this 1 to 2 hour session. Okay. So if we can slightly go back to what are variables, we know that variables are the characteristics of the interest that we observe in a sample. Okay. So they are, for example, name of a place or a person or an object. Okay. Or mode of delivery. Is it cephalic or breech? Pregnancy mode of delivery, that is cesarean or normal. Pregnancy outcome, is it good or bad? We can see that all of this fetal presentation is cephalic or breech. Placental proposition, is it anterior or lateral or posterior? All these are examples of nominal variables. Nominal variable means naming variables. That means they are all categorical data. They are not ordered and mutually exclusive. So there are two scales under which this categorical data are measured. The first lowest scale is the nominal scale. So they are mutually exclusive. Even the jersey numbers of the football team or the number 11 means Maradona, etc., are all naming variables. Okay. See, other examples are all this. You can see binary nominal variables, which we already discussed. The GDM status, is it positive or negative, is also a nominal variable. Preeclampsia status, that is also a nominal variable. Even what type of contraceptive method they are taking, it's the name of the contraceptive method. So what type of this blood group, name of the blood group, are all examples of nominal variables, are the categorical variables measured under the lowest scale, that is the nominal scale. The next scale is ranked, ordered, or given a grade or a scale. And for example, cervical cancer staging, stage 1, stage 2, grade 1, grade 2, grade 3. Even visual analog score that we give, number we give, based on the criteria, we give that number. So all this, and even Likert scale from 0, 1, 2, 3, 4, 5, or satisfaction ratings like mildly not satisfied, satisfied, very satisfied. All these are having a rank or an order. Okay, or they are having a scale, but the difference is not exact. What do you mean by that is, a person is having a pain score of 5. We cannot say that a person who is having a pain score of 10, he is having a twice amount of pain compared to a person who is having a pain score of 5. We cannot conclude that, because the difference between each stage or an order is not exact. For example, grade 4 staging means it is not 4 times cancerous than cervical grade 1. So it is not like that. So those are all called as measured under ordinal scale. So these are also again categorical data. So we discussed the nominal and ordinal scale of measurement. These are the examples. There are other examples also. You can see perennial tear severity staging, okay, endometriosis staging, even some of the, along with the clinical scores like Apgar score, Bishop score, they are all coming under the ordinal scale of measurement. So these are the some of the examples of the ordinal scale of measurement, the categorical variables. Now coming to the quantitative variables, they are measured in either interval or ratio scale. Now interval scale means they are number ordered. The difference is meaningful. That is the difference between the ordinal and the interval. The difference is meaningful, but there is no true zero. So, and hence they cannot be expressed as a ratio. What do you mean by that? Is, for example, temperature in degrees Celsius of 0 does not mean absence of temperature. Okay, but temperature of 0 Kelvin means absent of temperature. It is actually equal to minus 273 degrees Celsius. Okay, so now if an object is the temperature, measured temperature of an object is 100 degrees Celsius, and another object's measured temperature is, let us say, 50 degrees Celsius. We cannot conclude that the object B is twice hotter than the object A. Why we cannot conclude is, if we extrapolate it to the other scale, you can see, because it does not have an absolute zero, we cannot express this as a ratio. So such measurements are all called as the measured in interval scale of measurements, right? So date of birth, it does not have an absolute zero, IQ scores, etc. They're all quantitative data. The other examples, even gestational age measured by the last menstrual period, that is also can be considered as an interval variable, because last menstrual phase is an arbitrary phase. So all this where we cannot express as ratio or zero is not absolute are all classified under interval scale of measurement. The next scale of measurement are the ratio scale, where we can express them as ratio because true zero exists. Because true zero exists. For example, temperature in Kelvin or weight can be expressed as ratio. That means because true zero exists, a person who is weighing 100 kg, we can definitely say he is the ratio. Okay, the ratio between a person weighing 100 kg and 50 kg is 2. Or we can express A is equal to 2 times B. That means he weighs 2 times heavier than the person B, because it has absolute zero. Okay, so they can be expressed as ratios. So such scale of measurement is called as ratio scale of measurement. So all these are quantitative variables. The other examples are all SI derivatives, SI unit derivatives, height, weight, etc. are all measured under ratio scale. So summarize, the lowest scale of measurement of a categorical or qualitative variable is the nominal scale, naming variable. Next is the ordered ordinal variable. That is also categorical. And the next level of quantitative variable measurement is the interval scale, where there is no absolute zero. And the highest scale of measurement of a quantitative variable is the ratio scale of measurement. Okay, so this is the summary of what we have discussed just now. Now, what type of variable are these? For example, number of children, number of ANC, they are also quantitative variables, but they also can be classified into discrete, because they cannot assume any value in the spectrum. They can assume only whole numerical counts, 1, 2, 3, 4, like that. Okay. Whereas height, weight, time, etc., they can assume any value in the theoretical spectrum. That means these are all continuous variables. It can be 175 centimeters also. It can be 174 centimeters also. It can be 174.3 centimeters also. It can assume any value in the spectrum theoretically. So such variables are all called as, measured as, classified as continuous variables. Okay. So this is another way of classifying the quantitative variables. So a variable can be, quantitative variable can be discrete or continuous. Even a ratio scale of variable options will not be given. Both options will not be given for a quantitative variable. Okay. So what are the, now coming to the measures of central tendency. So which are the three measures of central tendency? One is the mean. The most commonly used is the mean. What is the mean? If you see, there are 5 women in this sample, and they are all weighing 40, 40, 45, 50, etc. Now, do you take the mean? We all know we add everything, and then we divide by the total number. Total number here is 5. So when we do that, we see that it will get a mean of weight of 45. Mean weight of 45. This is a very simple calculation of measure of the central tendency. Now, what happens when we take another sample wherein a woman with 80 kg got recruited from the same population? In this case, what will happen to the mean? Here, the mean will get affected. You can see from 45, it has moved towards the 51, because the mean gets drawn by the extreme outliers. Hence, mean is appropriate to be used as a measure of central tendency only when the population is normally distributed. Okay. So what measure of central tendency do we use when the data distribution is not normal? It is median. What is median? Median is also a measure of central tendency. It is the most central data. How do we calculate median? For suppose these are the data of the weight of the woman from a sample, and we can see first we have to sort it in increasing or decreasing order. Then we have to find out the centralmost number. Visually itself, when you sort it out, you can find that centralmost number is 45 because on either side equal number of data exists. Okay, so 45 is the median. However, there are formulas to calculate median also. If the n is odd, here it is n is 1, 2, 3, 4, 5. Sample size is 5. So it's an odd numbered data set. Then the formula is n plus 1 by 2th value. That means 5 plus 1 by 2. That is the third value. This we use only when the data set is very large. Otherwise, visually itself, we can calculate the central tendency. Mean is almost equal to median if the data is normally distributed. However, if we have an even numbered data set, for example, uric acid levels of women suffering from, let us say, gout. This is the data set. N is equal to 12 here. Okay. So after arranging them in and sorting them in an increasing or decreasing order, we have to always remember that there will be two values in the center whose average we have to take to calculate the median. If the data set is even numbered data set. Here, otherwise, these are the 4 and 4 are the centralmost values. If you take the average, it will be 4. 4 is the median of the even numbered data set here. The formula also we can use. The formula is the n by 2th value and the next value. N by 2th value is the 6th value and the next value is the 7th value. We can take the average of the n by 2th value and the next value. Here that would become 4. Okay, so the both formulas you can use. Okay, so however, if we go back to the mean where we have drawn the sample and the 80 kg overweight woman got recruited, in this case it affected the mean, but did it affect the median? You can see if you arrange it, the median is unaffected. Okay, so median is unaffected by the extreme outliers. It remains the same. Hence, median is the appropriate measure of central tendency to be used when the data set is not normally distributed, unlike mean. Okay, so mode is the most frequently occurring data. Here you can see data set 40 and 50 are occurring twice. It's a bimodal distribution. Most of the times it is used to represent most common presentation at delivery, most common type of complications, most common type of mode of presentations, etc. Most common type of delivery. All these are expressed as modes. Okay, so it is, as I discussed, used when we need most commonly occurring event. Now, range is the simplest measure of dispersion. It is the difference between the highest and the lowest number. Here, the range of weight is 40 to 50. And you can see, like mean, it also gets affected when the data set has an extreme outlier. For example, a woman with 80 kg, as we discussed earlier, the range gets affected. So, though this is the simplest measure of dispersion, not commonly used, but easy to understand. More is the variation, more is the range, more is the variation. So, to summarize, we discussed about the mean, median, and mode. So, mean, median, and mode. Okay. So, mean is the average. This is what they ask, average. And it gets affected by extreme outliers. Hence, it is better used as a measure of central tendency when the data is normally distributed. Median is the centralmost number. It is unaffected by the outliers and it is best used when the data set is not normally distributed. Mode is the most commonly occurring number, most common number. Okay. So these are the characteristics of the mean, median, and mode. Now coming to the measures of dispersion, we discussed the range. Let us see, we can calculate the mean, median, and mode here. So mean is the average. When we take the mean, when we add everything, it is 76 divided by 7 is 10.8 is the mean. What about the median? You have already arranged this in increasing order. You can see 1, 2, 3, 4, 5, 6, 7 data sets are there. It is the even number data set. So visually itself, you can see on either side of this 10, equal number of data exists. So 10 is the median. Otherwise, we can also find out by the formula n plus 1 by 2th value. So what is the n plus 1 by 2th value? That is the fourth value. N is 7. N plus 1 by 2 is the fourth value. That way also you can find. Mode is the most common value. Here it is 10 has occurred twice. So 10 is the most common value. So this is how we calculate the measure of central tendency. Similarly, you can use this data to calculate the mean. Definitely, it is an even set of data. 1, 2, 3, 4, 5, 6 data sets are there. Mean already, average, it is 2.7. What about median? Median will always be average of the centralmost two numbers, or n by 2th and the next. N is 6, n by 2 is the third value and the next value. You can take the average, that will become the median. Okay. So it is about 2.6 is the median. And of course, mode is the most commonly occurring, which is 2.4, which has occurred twice. So this is how we calculate. The best way is to arrange in increasing order and find out the central value. And if it is an odd number, it is the centralmost value. If it is the even number, it will be average of the two values, which are the most central. So that way we have to remember. If we can extend this to study how we can measure quartiles. Now you can see these are the scores of women who have appeared for the exams. N is 100, so even number data set. Highest score is 85, lowest score is 35. What is the median? Median, as we have told, in a even number data set is n by 2th and the next value. N by 2th is the 50th value and the next is the 51st value. So it is 58 and 59, average of these two numbers. So around 58.5 becomes the median. Median is also called as the 50th percentile. Median is also called as the 50th percentile, also called as quartile 2. Okay. Suppose this is the 50th percentile median. Now, what would be the 25th percentile? So, similarly, extrapolating this knowledge, it would be 1/4 the data and the next one. 1/4 is the 25th value and the 26th. Next one is 26. The average becomes the 25th percentile. So, this is the quartile 2. And then 25th percentile is called as the quartile 1. 25th percentile is called as the quartile 1. So, this becomes the quartile 1. Now, if this is the quartile 1, then what is the quartile 3? Okay, quartile 3 will be 3/4 the value and the next value. That means the 75th value and the next value, 76th value, average. That will become the quartile 3. Okay, that is also called as the 75th percentile, also called as the quartile 3. Okay, now if we have to say what percentage of women have scored lesser than quartile 1, that is the lesser than 45. Around 25% have scored lesser than 45. What percentage of women have scored more than quartile 3? That is marks 71. Again, 25% have scored more than quartile 3. Now, coming to the measure of dispersion. What percentage of women have scored between quartile 1 and quartile 3? That is 50% of the women have scored between marks 45 and 71. That is the and this data is called as the range is called as the interquartile range. Okay, it contains the 50% of the data set within it. Suppose the lowest score instead of 35 was 0 and the highest score instead of 85 was 100. Would it affect the interquartile range? It would not affect the interquartile range. Okay, that's why interquartile range is unaffected by the outliers and it is best used as a measure of dispersion along with the median when the data set is not normally distributed. Whereas when the data set is normally distributed, we use mean along with standard deviation as the measure of dispersion. Okay, so now let us see if we can calculate the median and interquartile range of the following. So these are the hemoglobin levels. What is the median? Okay, so you can see we already calculated this. This is the median. Okay, so this is the centralmost value. We already calculated it, quartile 2. To calculate interquartile range, we need to calculate quartile 1 and quartile 3. So you can see 9 becomes the quartile 1, because on either side 1 data set exists. Okay, that is a quartile 1. And 13 becomes the quartile 3 because on either side 1 data set exists. Okay, so the interquartile range is 9 to 13. Or you can use the formula. So for quartile 2, it is n plus 1 by 2th value. Whereas for quartile 1, it is n plus 1 by 4th value. So if it is n is 1, 2, 3, 4, 5, 6, 7 plus 1 by 4 is the second value. Okay. Similarly, n plus 1 into 3/4 the value is the sixth value. Okay. Like that also formula can be used. That is used only when we use the highest number of data sets. So simplest way is what we have now discussed. So the quartile 1 would be n plus 1 by 4th value. Okay, right. Quartile 3 would be n plus 1 into 3/4 value. Okay, like that also you can use, but I would prefer when the data set is lower to visually find out the median. Okay, right. So that is the median. Arrange in sorted manner. Find out if the data set is even or odd. If it is odd, use the centralmost number valued formula and then find out the interquartile range. Okay. Similarly, when the data set is even, so how do we find out? It is also arranged in sorted manner. Find out if it is even or odd. Here it becomes, the median becomes the average of the n by 2th and the n by this one next value. Whereas similarly, quartile 1 also will be 1/4 the value and the next value average. And quartile 3 is the 3/4 the value and the next value average. Okay. So that will become the data sets. Right. So here 3/4 this is 13 and 14 values. This will become the this one. Okay. If I have to go this. Yeah. Right. 13 and 14 average. Okay. So that will be the. Now similarly, you can take the average of 11 and 12 also here to be the average, and 14 and 16 average will be the quartile 3. So this is quartile 1, quartile 2 and quartile 3. Okay. So like that you can find out the median. Okay. So to summarize, we found out that when the data set is normally distributed, we use mean along with standard deviation. Okay, when the data set is not normally distributed, we use median along with interquartile range. Okay, so in a problem, if they give the sample statistics in median and IQR, you can presume it is not normally distributed data. And if we give the data in mean and sample statistics in mean and standard deviation, then you can presume the data set is normally distributed. Okay, so these are the simple features of the data sets, right? Now coming to visual representations, you can see how we can represent them in the graph. Height is a continuous variable, so you can divide how many people between 140 to 150, 10%. 152, sorry, or whatever, 1% or 10%. How many people between 145 to 150, 15, 20%, 30%. Like that, if you divide, and on the x-axis, you represent the continuous variable, and the y-axis, you represent the frequency distribution. Then these bars will get joined, and such graphical representation is called as the histogram. If you connect the centralmost points, we can draw a graph that is called as a curve, frequency polygon, and this is called as the frequency polygon. Okay. Whereas if on the x-axis, it is a discrete variable or a categorical variable, either categorical variable or a discrete variable. And on the y-axis, we represent the frequency distribution. Then what will happen? The bars will not join. Okay. So that is called as the bar graph. If the bars are not joining, that is called as the bar graph. So if you want to represent continuous variable and its relative frequency density, we use histogram. If you want to represent a categorical data or a discrete variable along with the relative frequency density, we use bar graph. The another advantage of the frequency polygon or the histogram is you can find out if the shape of the distribution is symmetric or not. Now, if it is symmetric, it is a normal distribution, or sometimes it may be positively skewed. So this is a positively skewed graph, or sometime it may be negatively skewed. So this is an example of negatively skewed graph. So shape of the distribution also can be found out using the shape of the distribution also can be found out using the histogram. Okay, so it can also be found out using the histogram. Okay, right. Okay, right. So it can also be found out using the histogram. So I think camera got changed anyway. Okay, right. Now, if we have to next, we will see the box whisker plot. So you know the box whisker plot, it is having a box. Okay. On the x-axis, you represent categorical data or discrete data. On y-axis, again, relative density or the frequency distribution or any continuous variable you can represent. Now, this is the plot that represents the relative salary drawn by male co-workers and female workers in a tertiary care hospital, hypothetically. Okay, so that is the what is the graph is representing. So why it is called as box is because you have a square and that is the box, and we have a whisker. We have a square and a whisker. Okay, so that's why we call it as a box whisker plot. So what does the centralmost line in this square represent? The centralmost line in this square represent median. So the median salary drawn by male co-workers here is 35 and females is around 25. Okay. Now what is the lower value? Lower line in the square box. It is the quartile 1. Okay. And it is around 30,000, and higher the highest line is the next line is the quartile 3. So okay, this line represents quartile 3. So 50,000 is the quartile 3 salary drawn. That means what does it represent? It represents that 25% of the males are drawing salary less than 30K. Similarly, 25% of the females are drawing salary less than 20K. 25% of the males are drawing salary more than 50K. Similarly, 25% of the females are drawing salary more than 30K. Okay, so that comparison you can do. Whereas 50% of the males are drawing salary between 30 to 50K, whereas 50% of the female are drawing salary between only 20 to 30K. So there is relatively very less variation in the salary drawn by women, and this is the interquartile range. The size of the square box represents the interquartile range. Okay, so central line is the median, upper line is the quartile 3, lower line is the quartile 1. These are the whiskers, and the size of the square box represents the interquartile range. Also, if we can see the sum of the salary drawn by male co-workers who happen to be MDs or so on, that's very high. So it is the mean, if we calculate, it comes to around 80,000. Is it a true representation of the measure of central tendency? No, because 80,000, if we are saying, and is the mean salary drawn by males, but the 50% of the males are drawing salary between 30 to 50,000, it won't be a appropriate measure of central tendency. Why it has happened is because of the outlier, skewed salary distribution. Okay, that is why. Now, if you see at the women, it is almost normally distributed. Okay, so even the way it is distributed also can be found out. So this is the box whisker plot and its identification. So they usually ask what identify the graph or to calculate the interquartile range. Also, you can use this knowledge to interpret the graph in the research related papers. Okay, so that is what you can use. Okay. Now we will move on to the standard dispersion. Okay, so we will move on to the standard dispersion, standard deviation. Okay, so standard deviation is not usually asked in the exams to calculate, because it's a complicated one, but we will try to understand what it is. Now 2.83 is the mean. Okay, how much is the variation from the first value? First value is 1. So this much variation. Second value is 2, very less variation. Third value is also 2, very less variation. Fourth value is positively little bit higher. Fifth value is little bit even more from the mean. Okay, and the last value is even bit more than the mean. If you add all the variations, some are plus and some are minus from the mean, it will, if it is normally distributed, it will be amounting to 0 almost. So in that way, we cannot calculate. So what we do is we square the differences. So we take the square and then we add it and then take the average variation. Okay. So we sum all the squared difference from the mean and then take the average. And this is called as squared variation. That is the variance. But we don't want the squared variation. So we take the square root, and that is called as standard deviation. So standard deviation is the square root of the sum of the squared mean difference. Okay. So it is also affected by the outliers. It is also affected by the outliers. More is the variation, more is the standard deviation. And as we discussed earlier, we use mean and SD together when the population is normally distributed. So, okay, this is about the standard deviation. Now we will see the normal distribution. So till now, what we discussed was coming under the topic descriptive biostatistics. Okay, so it was coming under the topic descriptive biostatistics. What we discussed till now was the collection of the data, organization of the data, summarization of the data, and analysis of part of the data. Okay. Collection of the data, we can do many methods: records, observation or experimentation or interview, organization into table or graph, summarizing into measures of central tendency and dispersion, which are called as the sample statistics. Okay. And then analyzing it, whether it is high or not. Now we will move on to the in-between topic, the type of distribution. The one distribution we will study today is normal distribution. Of course, there are many other types which are out of scope for today's discussion. So after studying, we'll move on to inferential part of the biostatistics, wherein we will study how we estimate the confidence interval and how we test our hypothesis using the inferential tests, So these two part is the inferential statistics. Okay. So suppose we take the we take the population, and if you take the sample population, it is a population size and it is a sample size, and from which we have taken the sample. Okay. Suppose it is the mean of the population, mean hemoglobin in the population, and this is the mean hemoglobin in the sample. So suppose this is the standard deviation of the hemoglobin levels in the population, and this is the standard deviation in the hemoglobin levels of the sample. Okay. So what we get is only the data, sample data, and that is called as the sample statistics. Okay. This is the sample statistics. So now we have discussed about the sample statistics, measures of central tendency and dispersion. From this, we would like to find out what would be the mean of the population or the variation in the population. So we cannot give a point estimate. We can give an interval estimate. Okay. So that interval estimate, what we can estimate from the sample statistics about the population parameter. What is the population parameter here? The mean value of the hemoglobin in the population or variation in the hemoglobin in the population. So the estimation of population parameter from the sample statistics with a certain degree of confidence, that interval estimate is called as the confidence interval. Okay, we can do calculate the confidence interval for not only the mean, also for mean difference, also for the hazard ratio, relative risk, or any proportions. Okay, we'll come back to that later. Right. So that is the idea what we are discussing. Now, what is the normal distribution? We all have discussed what is the normal distribution. We know what is normal distribution, right? So we all have discussed about that. And you can see the graph here is called as the bell-shaped curve because on either side it is equally symmetrical. The right shoulder is similar to the left shoulder. Okay, so on x-axis, if you represent a continuous variable whose mean you calculate and represent, whose standard deviation you calculate and represent the data set of mean plus 1 standard, 2 standard, and 3 standard deviation. Similarly, mean minus 1, minus 2, and minus 3 standard deviation data on the x-axis, and on the y-axis, you represent again the relative frequency distribution or probability density. You get a normal distribution curve, what is called as the bell-shaped or the Gaussian distribution curve. If that is the case, mean and median mode will be equal, okay? And it always follow what is called as the 68, 95, 99 rule. So what we will see, what is this 68, 95, 99 rule? Okay. So what does it say is 68% of the data will be between mean plus or minus 1 standard deviation. Okay. 68% of the data. Whereas 95% of the data will be between mean plus or minus 2 standard deviation. Similarly, 99.7% of the data will be between mean plus or minus 3 standard deviation. Suppose 95% of the data set is within plus or minus 2 standard deviation, then how many percent of the data set will be outside the mean plus or minus 2 standard deviation? Total will be 5%. Because it is symmetrically distributed, 2.5% will be more than mean plus 1 standard deviation. 2.5% of the data set will be less than mean minus 2 standard deviation. Similarly, we can extrapolate this knowledge to mean plus or minus 1 standard deviation. Around 68% are inside, 68% are inside. Then how many will be outside? Okay, around 32% will be outside. That means 16% will be more than plus 1 standard deviation. Another 16% will be less than minus 1 standard deviation. Using this, can we solve certain problems is what we are going to see now. Okay. Suppose total population size is 1000. Mean glucose is 110. I will draw so that you can understand that. Mean glucose is 110. Standard deviation of the glucose is 12.5. 12.5. Now, what is this plus 1 standard value? It is around 112.5. Plus 2 standard deviation value will be around 125. Minus 1, let us be something. Minus 2 standard deviation is something. And it is normally distributed. Now, you can see it is normally distributed. Now, what is the question? How many of them can be diabetic? How many of them can be diabetic? Now, you can see this is plus 2 standard. This is the mean. This is the plus 1 standard value, mean plus 2 standard deviation value. Okay. And this is the minus 1 SD value. And this is the minus 2 SD value. So what is the question they ask is how many can be diabetic? How many can be diabetic? This is a normal distributed value. Now what is diabetes by WHO criteria? Value more than 125 milligram per deciliter can be classified as diabetic. So we would like to know how many are more than this 125. This is mean plus or plus 2 standard deviation value. But we already know from this, that 95% of the data set, 95% of the data set are having 95% of the data set are having between minus 2 SD to 125. So how many will be outside? 5%. 5% is outside. We know that 2.5% will be having value data set more than 125. That is a plus 2 SD, and 2.5% will be minus 2 SD. So what is this? Having around 2.5% of the population will be more than having the blood glucose more than 125 milligram per deciliter. That means 2.5% of 1000 would be 25. Around 25 can be diabetic. Okay, so around 25 can be diabetic. Another question is, how many of them can be impaired glucose tolerance? By WHO method, we know that impaired glucose tolerance, whoever is having data set between 110 to 125, can be classified as a pre-diabetic, that is the suffering from impaired glucose tolerance. So you can see 95% is having the data set between mean plus or minus 1 standard deviation, 2 standard deviation. This is the half of it. So 95% half is around 47.5% of the women here are having impaired glucose tolerance. That means around 475, 47.5% of the 1000 is around 475 women in this population are suffering from impaired glucose tolerance. So this way, we can also find out the other examples if we have to see for those who are not understood. So the mean cholesterol is 175, SD is 25 means it is 200, 225 and 250 is the 3SD. Minus 1SD is 150, minus 2SD is 125, minus 3SD is 100. Now the question here is how many need treatment? By the virtue of our NCEP program, we know that whoever is having more than 200 milligram per deciliter needs treatment. So more than 200 is more than plus 1 SD. That means how much we calculate? Within 1 plus or minus 1 SD, 68% will have. On outside, 32%. More than 1 SD is around 16%. Approximately 16% of the 1000 is around 160. Okay, so around 160 women here may need treatment is our diagnosis. Similarly, you can see if the BMI is 25 and SD is 2.5 plus 2 SD is 27.5 plus 3 SD is 30. The question they asked is how many are class 1 obese? The question they have asked is how many are class 1 obese? So you can see it is class 1 obese means here it is going up to plus or minus 3 SD. Okay. 3 SD means 99%, 99.7%. Okay, 25, 27.5 and 30. More than 30 is class 1 obese. Only around 0.3 percent are outside plus or minus 3 SD and around 0.15% are outside the plus 3 SD value. Okay, divided by 2. So that's around 0.15 means around 15 people, around 1.5 to 15 people will be having class 1 obesity. So like that, different problems can be solved based on this. Now looking at this distribution, which distribution has mean, median and mode similar? It is the centralmost data. Okay, in which this type of distribution mean will be more? It is the positively skewed distribution where mean will be drawn outside towards it on the higher side, and equal is symmetrical distribution, and in the negatively skewed distribution mean will be lesser than the median. Mean will be lesser than the median. Okay, these are another simple questions that are asked. Okay, let's see some. Right. Now that we have discussed this, we will move on to the estimation part, confidence interval. Now here, you should carefully see what I am going to tell. Okay. Right. Now, suppose this is the population where the population size is 5 and this is the sample. The sample size is 2. How many probable samples we can take? N raised to n. Around 25 different probable samples can be drawn by replacement. Okay. So 1 and 1, 1 and 3, 1 and 4, 1 and 5, 2 and 1, 2 and 3, 2 and like that. So 25 different samples can be drawn. Now each sample when we draw, we can calculate the mean. Okay, so 25 different means we can say that those means are called as sample probable means. Suppose I plot this. This is the first sample probable mean, second, third, fourth, fifth, etc. and etc. So you can find out that these sample probable means are always normally distributed, regardless of the distribution of the population from which the sample are drawn. Sample probable mean are always normally distributed. This is one idiom rule in the statistics. Now, how much is this sample probable mean varying? How much is this sample probable mean varying? And that term is called as the standard error of mean. That is called as the standard error of mean. So what is standard error of mean? How much is the sample probable means are varying? It is nothing but variation in the means. Okay. Now we already know standard error of mean. Another rule states that it is equal to standard deviation of the population parameter divided by the square root of the sample size. It is almost equal, always equal. Okay. Now what we know here is the sample size. Because we have taken the sample. But do we know anything about the population? We don't know. So what we do is we presume that whenever we take a sample, it is very similar to closely resembles the population. It closely resembles the population. That's why there is less sampling error and sample SD is similar to population SD. So we have got a sample, we have got mean of the sample, we have got SD of the sample. Then we put it here. We calculate the standard error of mean. Now we extrapolate the knowledge of the normal distribution. So what percentage of this is distributed here? This is the mean and this is the 2 standard error of mean. Okay. And this data is the -2 standard error of mean. How much it will be between this? 95%. Okay. What does it mean? There is a 95% chance that the population mean is somewhere between mean plus or minus 2 standard error of mean. That means we are giving an interval estimate where the population parameter could lie. Okay. So that is the confidence interval. So if you have to calculate the confidence interval, what it is a confidence interval is calculated by the sample statistics. It is an interval estimate. What it says? It says what is the probability that the population parameter lies within it. Okay, that is the definition of a confidence interval. Suppose we take the less sample size. What will happen to the confidence interval? If you take the less sample size, you can see it is the denominator. This value will be less. And what will happen to the width of the confidence interval? Width of the confidence interval will be narrow. If you take if you take less sample size, this will be high. The standard error of mean will be high and the width of the confidence interval will be broader. Interval estimate will be broader. That means if we repeat the experiment, we may get different values. That means the reliability of the study is poor. So the width of the confidence interval tells us about the reliability of the study. It is affected by the sample size. So we have to take a very good amount of sample size to improve the reliability of the study, Okay. Okay. So the question here is, if the confidence interval is more, what is this? Our study reliability is poor. Okay. Now, if we take the standard deviation, what is the chance of standard deviation affecting the confidence interval? If we draw a sample which is not closely resembling the population, the standard deviation is high. Then again, confidence interval width will be high. So you can see here, we'll explain this. Standard deviation is high, confidence interval is also high. So how to minimize this? You have to take a sample which is closely resembling the population. Okay. So how to minimize this? So you have to take a good sample size and you have to decrease the standard deviation. How to minimize the standard deviation? Variation in the sample by taking a sample resembling the population. Then that way you can narrow the confidence interval and improve the reliability of the study. Okay. So the question is, when the sample size is more, what will happen to the confidence interval? Okay. So mean confidence interval is equal to mean plus or minus z times the standard error of mean. This is the confidence interval of mean. Okay. Okay. So z is 2. Okay, 2 or 1.96 if it is a 95% confidence interval. Okay, now what is SEM? It is SD by square root of n. So if our sample size is low, or if the standard deviation, variation in the sample is high, then the confidence interval is broad. If the confidence interval is broad, then reliability is less. So sometimes they ask this question, okay, what is the effect of the sample size? So this is the effect. Okay, we'll see that with the problem. We'll see how to calculate the confidence interval. So that is the problem. Okay, in a study, 49 men with COVID infection, the LDH recorded was 700 milligrams per deciliter and the standard deviation was 70. What is the 95% confidence interval? So this is the COVID infected men, okay, whose LDH we would like to know, mean LDH we would like to know in the population. Since we cannot include everyone in the population, we took a sample size of 49, okay, and then whose mean we estimated, LDH mean we estimated, it amounts to be around 700. From this and a standard deviation in the sample was around 70. So a lot of variation is there in the sample, okay, so 70 variation is there. Now from this we would like to estimate what would be the population mean, that is the LDH in the men suffering from COVID in the population. So we give an estimate. That estimate is confidence interval. So what is the formula? So first we have to calculate the standard error of mean. So standard error of mean is equal to standard deviation divided by the square root of the sample size. Okay. Now what is the standard deviation measured here? It is equal to 70. Square root of sample size is square root of 49. Sample size is 49. So it will be amount to 70 by 7, that is 10. So standard error of mean is 10. What is the formula we have done to calculate the confidence interval of mean? Confidence 95% confidence interval of mean is equal to mean plus or minus 2 times standard error of mean. Using this, if we calculate, it is equal to 700 plus or minus 2 times the standard error of mean is 10. So there is confidence interval is 680 to 720. What does it mean? There is a 95% chance that this population mean of the LDH in COVID men is somewhere between 680 to 720. It is somewhere between this. There is a 95% chance that this is somewhere between this. This is how we calculate the confidence interval and this is how we interpret this confidence interval. Similarly, this is the answer. Similarly, if we have to calculate the confidence interval of, let us say one more problem, 64 women with obesity. So n is equal to 64. Mean cholesterol was 160. Standard deviation was 16. Then we have to calculate. So standard error is, we know SD by square root of n. So 16 by square root of 64. It is equal to 2. And standard confidence interval is mean plus or minus 2 times standard error. So 160 plus or minus 2 into 2. It is 156 to 164. Okay, these are the two problems with which we understood how to calculate the confidence interval and what will affect the confidence interval. That is the sample size and the standard deviation will affect the confidence interval. So these are the questions that they will ask about the confidence interval. Now that the estimation part is over, we will see what is this hypothesis testing. So you know what is hypothesis? Hypothesis is a statement that we make by the virtue of our observation or expertise or experience or our thinking, okay, upon which we make the statement. For example, we observe in the ward, that antenatal ward, that anemic women are having more PPH, postpartum hemorrhage. That is our observation. That is a statement we make based on a scientific principle. We make that. Okay. Now that we have to operationalize this statement. What is this operationalization? You can see here that statement has been changed into women with less than hemoglobin of less than 10. So we know who are anemic. Compared to women with more than 10. What we are comparing? Incidence of PPH. Incidence of PPH. So in whom we are doing, what we are comparing, everything is operationalized. And this is called as the scientific hypothesis or the operationalized hypothesis or alternative hypothesis. Now, null hypothesis means it always states the null effect. The null effect here is there is no difference in PPH between anemic and a non-anemic women. That is the null hypothesis. It always states the null effect. Now, what is the p-value? P-value is the probability. P for probability. What probability? The probability that whatever we are observing is due to chance. Assuming that the null hypothesis is true. Now, if the p-value is less than 5%, that means the probability that our study finding, whatever we are observing is due to chance is less than 5%. That is the 95% of the times it may be the other. That means it may be an important finding. Okay. Now, if the p-value is less than 1%, the probability that whatever we have observed in our study, what we are deriving, is due to chance is less than 1%. That means our study is even very highly significant finding. If the p-value is less than 0.1%, then we reject the null hypothesis in all these situations and conclude this as very highly significant finding. Why only these particular numbers are chosen? It is arbitrary. Okay, there is no real scientific explanation for why only 5, 1 and 0.1% are chosen. Okay. Now, so just because p-value is significant, we cannot conclude that the effect is clinically significant. The meaning of this is, suppose we take 1,000 women. Before treatment, their BP was around 148, and after treatment, the BP came down to 146 millimeters of mercury. Okay, and you can see that the effect change is only 2 millimeters of mercury. The clinically, this difference is not very significant. However, the smallest of the change can be statistically detected significantly because the sample size is high. Okay, so who will determine the clinical significance? We have to determine by looking at the effect size. Just because a statistical significance, it will not prove that it is a clinically significant finding. So this is one other knowledge you have to take home. Now, coming to types of error and its questions related to the types of error, we will see that this is a crude picture, but it will drive home the point clearly. Suppose you have to observe what I am drawing. Suppose this is the actual finding and our study also concludes the same. Then it is the true positive finding. What is this true positive finding? It is always called as the power. Okay, it's always called as the power. The minimum expected power is more than 80%. Now you can see this is the finding. There is no finding actually in the study. And our study also concludes the same. In the field also, it is negative. Study also negative. True negative. And this is called as the confidence in our study. And the minimum expected confidence in our study should be more than 95%. Okay. Now let us look into the errors. Let us look into the errors. Now the finding is not present. Finding is not present. But what has happened here is, this is the finding is not present, but our study is giving a positive finding. So it is false positive finding. False positive finding. And this is called as alpha error. The other name for alpha error is the type 1 error. So, okay, this is a false positive finding. The minimum tolerable false positive finding should be less than 5%. Similarly, if this is the finding in the field, our study gives negative, false negative finding. Okay, this is called as the beta error, also called as the type 2 error, also called as the type 2 error. The minimum tolerable beta error in any study should be less than 20%. Okay, now that we know this, by probability principles, we know number of false positives plus number of true positives will be equal to 100. Will be equal to 100. That means true positive means power. If you know the power, you can calculate the beta error. That is beta error plus power is equal to 100. Sometimes they ask the question, if the power is 90%, what is the beta error? Beta error is 10%. If the beta error is 5%, what is the power? The power will be 95%. So such questions sometimes are asked related to this. Okay. Now that we know what is the true positive and true negative, I will move on to null hypothesis statements. Here, you have to observe what I am trying to tell. Suppose in males and females, we know that the creatinine level is around a little bit higher in males because of the muscle mass, little bit higher. It ranges from 0.7 to 1.4, whereas in females it ranges from 0.6 to 1.2 milligrams per deciliter. Right. Now, what does our experience say? It says that creatinine level is little bit more in males compared to females. Little bit more in males compared to females. This is the our scientific hypothesis. What about the null hypothesis? Null hypothesis always says null finding. Null finding is creatinine in males is there is no difference between creatinine in females. No difference. No difference. This is the null hypothesis. Okay. Now, is this null hypothesis statement true? No, it is not true. We know that it is a false statement. So when this null hypothesis is false, what our study should do? It should reject this null hypothesis and conclude that creatinine in male is more than female, little bit more than female. Okay, that is a true positive finding. So if we correctly reject a false null hypothesis, if we correctly reject a false null hypothesis, then it is called as power. Sometimes they give when the null hypothesis is rejected, when it is false, it is power. Okay. Now we will see the error that can be committed here. If you don't reject this, what will happen? If you don't reject this, this is what is going to happen. That means we fail to reject. The word is not, this accepted word is not correct. We fail to reject just because of, you want to understand, I'm using the word accepted. So it is failed to reject. Now what will happen? If you fails to reject a false null hypothesis, what we will conclude is, we'll conclude this hypothesis could be right. That means there is no difference in creatinine between males and females is what we conclude. Then it is a false negative. We know there is a difference, and that is called as beta error. That means null hypothesis is accepted, that is failed to rejected when false, NIAF, beta error. This mnemonic you can remember. Null hypothesis is accepted when false, beta error. Okay. So now we will see another statement where I am going to make a statement regarding the glucose values. We know that glucose values, okay, are very similar in males compared to females. Okay. So it is very similar. What is the null hypothesis here? Null finding telling hypothesis that it is no difference. No difference in glucose values between males and females is our null hypothesis. Now, is this the true statement? Yes, it is indeed true. Then what we have to do? If it is a true statement, we need to accept it. We need to accept it. That means fail to reject this null hypothesis, and then we conclude that there is no difference in glucose between males and females. True negative. Okay. If we fail to reject, instead of accepting, we reject it. What happens? Once we reject this statement that there is no difference in glucose between males and females, we conclude that there is a difference in males and females. Glucose is more in males compared to females. It's a false positive finding. That means in this case, null hypothesis is rejected when true. It is called as A, alpha error. Null hypothesis is rejected when true, alpha error. So this is the statement for alpha error. Now, if you have to summarize this, this is the null hypothesis statement they will give and ask us to identify. Now, how do we identify what it is? Okay, so whenever there is a word coming as rejected, okay, null hypothesis is rejected, either it is alpha error or it is power. Okay, whenever the word is fail to reject or accept, either it is confidence or it is beta error. Okay, that way we can rule out two things. Okay, now we will see and also use the mnemonic. Null hypothesis is rejected when true, alpha error. Null hypothesis is accepted when false, is beta error, NIAFB. This mnemonic also can be used. Let us see if we can derive that. Here you can see the statement. They will ask, null hypothesis is rejected when true. What type of error or power it is. Okay. So null hypothesis is rejected. Either it is power or alpha error. When true means we are rejecting a null hypothesis when it is true. Instead, we should not have rejected it. So it is alpha error. Null hypothesis is rejected when true. Alpha error. NIRTA. Okay. We just now discussed that. The same sentence is now written in a different form. Null hypothesis is rejected. Okay. We know either then now by this only we know either it is power or alpha error when there is no difference between the groups. Okay. When there is no difference between the groups, still we are rejecting the null hypothesis and saying that there is a difference. That means what? It is a false positive finding. No, it is nothing but alpha error, false positive. Okay. The same sentences mean the same, different way. Okay. Now, similarly, we will look into another null hypothesis is not rejected. Null hypothesis is not rejected means accepted when false. That means NIAF. What it is? Beta error. Okay. So not rejected means it can be only two things, either confidence or beta error. The same thing, different statement. Null hypothesis is not rejected. So now the two options are power confidence or beta error. When there is difference between two groups, there is a difference between two groups. Okay, we should have rejected the null hypothesis, but here we are not rejecting the null hypothesis and we are saying there is no difference. That means we are giving false negative value, false negative finding, which is nothing but the beta error. Okay, same sentence in a different form. Now, what about power? Null hypothesis correctly rejected when false. So, correctly rejected when false. It is power. So, they will ask us to identify this statement in the single best answer options. Okay. So, that is about the power and error. Right. Now, coming to inferential tests. Coming to the inferential tests. So, what we are going to use? Which test we will use when? So, there are usually two types of tests. One is the parametric tests. Another one is the non-parametric tests. So, when do we use a parametric test? We use the parametric test when the data is normally distributed. When we use the non-parametric equivalent test, when the data is not normally distributed. This is one of the assumptions to choose. There are many other assumptions, but we'll discuss that not today. Okay. Now, how do we know if the data set is normally distributed? Usually in the data, mean and SD are given as the representation of the measures of central tendency to summarize. Whereas median or IQR are given in the problem. Okay. And we can, from this conclude the data set is not normally distributed. Okay. So that is how we can conclude. Or it will be stated that it is normally distributed or not normally distributed in the problem itself. In the problem itself. Okay. Right. So that is how we identify whether the data set is normally distributed or not. Okay. Now that we know what are the parametric tests and what are the non-parametric tests, now we will see one by one what is the scenario and how we can find. Suppose the question is, which test you will use to find if the hemoglobin is different in this sample compared to a known population. In this sample, it is 10.8 mean hemoglobin, and in that population, the mean hemoglobin population was around 11.5. Okay, we are only taking sample. We are not taking the population. Per data, we already know about this. This data, we already know about this. So in this case, what is the hemoglobin status? Hemoglobin is a continuous variable. There are how many group? Only one group. One group sample we are taking. We are comparing with it a reference value from the known population. Okay. In such a case, and this data set is normally distributed. The data set is normally distributed. So in such a state, if you want to find out a difference of a continuous variable in a known group from the reference group, known sample from the reference group, and if the data set is normally distributed, we use the test what is called as the one sample t-test. One sample t-test. Okay, this is one sample t-test. When we use this, If you want to compare one sample against the population value. If it is not normally distributed, the non-parametric equivalent is called as the one sample Wilcoxon sign rank test. One sample Wilcoxon sign rank test. Okay. Now we will see the two sets. Now birth weight is there. We would like to see if there is a difference in birth weight between women with GDM and women without GDM. So we know birth weight is a continuous variable whose significance of the difference in two groups, two independent categorical groups are there, GDM versus no GDM. These are independent groups because the sample population in GDM will not be there in no GDM. They are mutually exclusive. They are not related. They are unpaired. They are independent. Okay. So if you want to find out the significance of a continuous variable distribution between two independent groups and the sample is, the data is normally distributed in the group, both the group, then the parametric test we use is called as the t-test. The other names of the t-test is independent t-test, student t-test, are also called as the unpaired t-test. All mean the same. Okay. All these mean the same. Suppose this is not normally distributed in one of the group or both the group. The alternative non-parametric equivalent to independent t-test is the Mann-Whitney U-test. The name of the test is called as the Mann-Whitney U-test. Now look at the confidence interval of the mean difference here. It is 0.8 to 1.4. Okay, if at all the mean difference is 0, that means there is no difference. Okay, does the confidence interval include the null value of 0 within it? No, it is 0.8 to 1.4. No, that's why it is significant. So the another statement that we can make here is if the confidence interval does not include null value within it, then the finding is significant. So two things we can find out. The width of the confidence interval, we can find out about the reliability and about the about the significance. If the null value is not within the interval, we can find out the significance. So we can find out if it is normally distributed or not, as I already discussed, that it will be either given in the problem that the data set is normally distributed or not normally distributed, or it is the data is referred as mean and standard deviation. Okay, summarized as mean and standard deviation, then we have to presume that the data set is normally distributed. If it is referred as median and interquartile range, then we have to presume that the data set is not normally distributed. Or we can, the options, both options will not be given in the answer. Independent t-test and Mann-Whitney test, both options will not be given. Now let us see the birth weight. Is it different in women with normal weight, in women with overweight, and in women with who are obese? Is the birth weight different? You know, the birth weight is a continuous variable and there are more than two independent categorical groups, and these are all mutually exclusive, independent. Okay, each group is independent of the other. In such a case, if you want to find out the significance of a difference in a continuous variable in in more than two groups, then this is the extension of the t-test. Extension of the t-test. T-test is two groups and here it is three groups. Okay, sorry, more than two groups. It can be anything. Then it is normally distributed in one group or all the groups. Then the parametric test used is the ANOVA. If it is not, then the alternative non-parametric equivalent is Kruskal-Wallis test. The alternative non-parametric equivalent is Kruskal-Wallis test. Okay. Now we will see, suppose we want to measure vaginal resting pressure. You know, it is a continuous variable. In whom are we measuring? In the same woman when she was at 21st week and the same woman when she is at 6th week postpartum. So you can see this group is related. Two groups are there, two groups are there, but they are paired groups. Okay, they are related groups. They are not independent. In such a case, if you want to find out the significance of a difference in a continuous variable between two paired groups and that variable is normally distributed, the test used is pair t-test. If it is not normally distributed, the alternative non-parametric equivalent to pair t-test is called as the Wilcoxon sign rank test, which is what we are going to use. Okay. So now you can see the confidence interval of the mean difference in vaginal resting pressure is little bit broader. And so you can say the reliability of this finding may be low. Probably could be due to low sample size or high variation. However, the mean difference null value 0 is still not here. It is still significant. It is not within the confidence interval. It is still significant. So uh, this is the variation. Now we will see the difference. Now when the same thing, but here what is happening? It is an extension of the pair t-test. Instead of two paired testing, there are more than two. So fasting blood glucose, we are measuring at 24-week, 28-week, 32-week, 36-week, etc. So what has happened? Same woman, we are taking the measurement 2 or 3 times. So it's a paired group, but it is more than two. And the continuous variable distribution, we would like to see is there any difference when we measure it repeatedly. And it is normally distributed. Okay, then the test used is called as RM ANOVA, repeated measures ANOVA test. If it is not normally distributed, the alternative equivalent is the Friedman's test. The alternative equivalent is the Friedman's test. This is an extension of the parity test. Now we will come into the categorical variable. Okay, now smoking status. Smoking status. What type of variable it is? It is a categorical variable, correct? Whether they may be yes or no, smokers or non-smokers. And depending on the birth weight, whether they are low birth weight or normal birth weight category. This is also a categorical variable. Okay. So we have one categorical variable and two categorical. Smoking status and birth weight category. Now, if I want to know whether the birth weight status is associated with smoking status of women. Okay, whether the birth weight status is associated with the smoking status of women or whether the person will be low or high birth, that means the birth weight status is independent of the smoking status. That means if one categorical variable is it associated or related to another categorical variable, if one categorical variable is independent of the other categorical variable, or suppose here around 30%, okay, of them smokers are low birth weight and the 70%, let us say 70% are normal birth weight and 20% of non-smokers are 20% of non-smoker, 80% will make 80% of the non-smokers are low birth weight, 20%. Okay. I will just okay. So 30% of the smokers are low birth weight and around 75% are normal birth, whereas only 20% of the non-smokers, only 20% of them are low birth and remaining 80% is normal birth. Okay, this is the proportion. So 30 out of 100 low birth are smokers, 20 out of 100 low birth are non-smokers, 70 out of 100 normal birth are smokers, and the remaining. Okay, so if we conclude this, okay, if we conclude, let us say 100. Okay, then what will happen? This proportion, is there a difference in proportion? Who is having more low birth? So if you take the more low birth count, it will be smokers. So difference in proportions, difference in category. In that we use what is called as chi-square test. If the sample size is less, then we use Fisher exact test. Okay. So when to find out the association between two categorical variables, to find out if the one categorical variable is independent of the other, to find out if there is a difference in proportions between two categories, difference in proportions, then we use chi-square test. Okay. Now, if the chi-square test has to be extended, if the chi-square test has to be extended, okay. Okay, so in another, what is this McNamara test? Now, McNamara test is categorical variable only, but the two groups are there, no? They are same, related. Categorical variable, folic acid, if they are taking yes or no, is categorical variable. Before intervention and after intervention is also categorical variable. Whether there is a difference, because these groups are related. Okay. So if this group are related, then we use McNamara's test. Then we use the McNamara test. Okay. So when do we use Pearson correlation test? If you want to find out to measure the strength and direction of the association, the two variables are continuous and two variables are linearly related and variables are normally distributed. Then we use Pearson correlation test. For example, BMI is also continuous, BP is also continuous. Okay. So then we use, if you want to find out as BMI increases, whether BP increases, as BP increases, whether BMI increases, and both are continuous and normally distributed, then we use Pearson test. If one of them is and both of them are not normally distributed, then we use Spearman's correlation test. The other test is Spearman correlation test. To find out the strength, we use and direction, we use the R value. R value can be from -1 to +1. If it is plus, because you can conclude that the association is positive. As one increases, the other increases. If it is minus, we conclude that as iron increases, the TABC decreases. That is a negative association. And if it is more than 0.7, we conclude the strength is strong. And if the R value is less than 0.3, we conclude the strength is weak. Okay. So that is how we use the R value to find out the Pearson correlation test. Just because one is associated, we cannot conclude that one is the cause of the other. For example, we can see that brain size, IQ and foot size of a child is strongly associated. Does it mean foot is responsible for IQ? No. As the child grows, so does the brain and as well as the foot. Actually, the brain size is responsible for IQ. So just don't presume causation when there is a correlation. Sometimes they ask this question that whether the Pearson test means causing or means it improves causation or not. Okay. So in the and coming to the regression test. Okay. Coming to the regression test. So when do we use regression test? I will use this to see the regression test. If you want to predict, let us say GFR from, let us say creatinine. Okay. So which is the dependent variable here? Predict. The word is predict. Or let us say quantify. Or let us say the word is find out the effect of one on the other. If these three words are there, and that means one variable is, this is dependent. Which is the dependent variable? This one. Okay, GFR. This is the dependent variable. Which is the independent variable here? Creatinine. Independent variable is also called as predictor variable. Okay. Okay. Now, what is the dependent variable type here? Continuous. If the dependent variable is continuous and there is only one predictor variable, we use what is called as simple linear regression. Simple linear regression. Now, instead of that, if there are dependent variables are more, let us say GFR, you would like to predict or find out the effect of creatinine as well as the age as well as the gender, etc. on GFR. On GFR. Find out the effect, predict, quantify GFR from these independent predictor variables. Now, what is the dependent variable? This is continuous. How many independent variables are there? More than one. Then we use what is called as multiple linear regression. Now, if the dependent variable is outcome, let us say, what type of variable is, we want to find out the pregnancy outcome based on the age of the woman at the time of the delivery, or let us say based on the hemoglobin status at the time of the delivery, etc., etc. Outcome is a categorical variable. That is a dependent variable. If the dependent variable is categorical, and if you want to find out the effect of predictor variables, independent predictor variables on this categorical variable, then we use logistic regression. Okay. So simple linear regression, multiple linear regression, and logistic regression. Okay. Now, if you see the summarize one sample t-test, what is the alternative? One sample Wilcoxon sign rank test. When do we use? One group versus the known population, continuous variable. Two sample t-test, the alternative is Mann-Whitney U test. When do you use? To find out the continuous variable difference between two independent groups. And one way ANOVA, more than two independent groups. Alternative is Kruskal-Wallis test. Okay. Now, between two paired groups, it is paired t-test. Alternative is Wilcoxon sign rank test. Okay. And more than one paired group, RM ANOVA, and it is Friedman's test. Alternative is the Friedman test. Okay. So this is the summary of the findings. This is the summary of the findings. Okay. All right. Okay. I think till now we discussed about the variables, and we discussed about the measures of the central tendency, and we discussed about the inferential tests, etc. So in this allotted 1 hour time, I have discussed this many topics. The remaining things I think we can discuss in the groups. And thank you for attending. We shall be ending this as another madam has come. Welcome to madam, and we will continue this. Thank you.
Thank you, Avinash. Thank you so much. Sorry, I think you almost took half an hour extra, but that's fine. Thank you, dear. Thank you so much. I'm sure they would have enjoyed the session. Thank you. Okay, so guys, welcome back once again. So yes, I hope my screen is visible, Anusha. Anusha's screen is visible, right?
Yes, ma'am. Yes, yes.
Okay, fantastic. So guys, thank you so much. So today I would be taking care of clinical governance. I have got around 100 plus slides. So we would be going ahead from the simple to the complex ones which you get in the exams. So I'm sure you already would have got a hang of the how we are going to do it. So obviously the concepts. Okay, Bontu Srividya, you must stop writing, darling. Okay, otherwise it would be very difficult for me. So please don't write, all of you, so that it is easy for me. Okay, don't write on the screens, guys. So yes, coming back to the things, what we shall do is we will start from concepts to your SBA pulse, so that even the EMQ and the commonest question which you guys are worried of. So that's what I would be covering. Okay. So coming to the weightage, because clinical governance questions are not too many, but when you will get so many at a time that you might be worried. Okay, like 5 questions. But if you're as an overseas candidate, it is always about the concepts and a few things. If you are aware, I think you would do better, because 100% there are questions on consent and capacity, education and training. You could see the emphasis will be on these high yielding topics: audit and research, risk management, ethics, patient safety. They are all medium. Confidentiality and definition, they carry very less questions. So basically I am going to cover all these things, plus the recently tested concepts also will be covering. Okay guys, so let's start with the definition. I am not going through the complete definition of the clinical governance. Just be aware, clinical governance is nothing but the medical common sense. So because we have to be continuously accountable for improving the quality, and of course you have to create an environment which is non-blame culture and excellence, where clinical care will flourish. Do you think the questions it would be on this? We would see as we move forward. Of course, the 7 pillars of clinical governance would be clinical effectiveness and research. That's where your clinical guidelines comes. That's the reason GTG, NICE, talks, all of them come in. Audit measures your clinical practice. You have been given a protocol, how well you are sticking to it. That is what the clinical audit does. Risk management, there could be errors which are iatrogenic, which are system-wise errors, but how would you manage them and prevent them happening in the future? Education and training is an integral part for any healthcare system. So how are you going to understand the training part, assessment part, ARCP, which would be the integral part of your exam, patient and public involvement, 100% this is NHS will work on. There are a lot of things. For example, the simplest one I would say is Montgomery ruling came in because of one single case. How well the sensitive information, the data analysis, the Caldecott principles are handled, and how the staffs are managed. These are basically the simple 7 pillars of clinical governance. And I wouldn't go into the detail. You are supposed to be knowing only this part of it. Corporate governance is not our headache. Research to some extent, yes, because you need to know about the good practice, you need to know about the ethics, all those things. But corporate governance to some extent, we need not worry. Okay, but you need to know there are different types of governance involved. Now, there are few questions which could, just to clear the concepts which we already discussed, which is the one which best describes the central aim of clinical governance. Why do you even need to know? So if you see all this, I always ask about doing a cover test where once you read the question, you should always think what could be the answer and look for it. As we already said, clinical governance part is to improve the quality continuously and to make sure that we are accountable. Correct? I think this is very, very important. Okay. So if you see this, I have not seen the answers. If you see the first one, continuous quality improvement, is that correct? Yes. Financial probity? No. Approval of research ethics? No. Individual annual appraisals? No. Disciplinary action against staff? No. So obviously A is the answer. We will see the answer in the next one as well. Which one of the following is one of the 7 pillars? Audit, yes. Tax compliance, no. Estate management, no. Marketing strategy, no. Procurement rendering, no. I hope your exams were as easy as this. It is never so easy. Anyways, just to keep your concepts clear, once you do through the questions, you would always remember. As I mentioned, clinical governance is always a continuous quality, and clinical audit is one of the 7 pillars. So guys, I know you are not able to open your microphone or video, but I'm sure you can send some reactions. Hope you're all happy so far. So because these are basic ones, so that's the reason I'm not wasting a lot of time. So if you're okay, you can send the reaction so I would know that you're all with me. Are you all okay guys? So far, so good. Now, what is clinical audit? Why you need to be knowing about, and what is the difference between audit and research? Basically, it is like, let's assume, take a common example. You have got a song where lyrics and tone is already fixed. Okay, you have heard a song, and now how correctly you are using the tune, how correctly you are using the lyrics and script, whatever of the original song, they would be monitoring that. That is what the audit is. Okay, so you've already got the script, you have already got the tune for the song. How well you are singing to that is what the clinical audit measures, the actual practice and the best practice, whether you are incomparable. But if you are somebody who is trying to figure out the lyrics and tune of the song, that is research. I hope I am clear with this. Research is finding out the new guidelines or new evidences, but audit is something which would see whether you are sticking with the protocols. Okay, and audit is never done for single case. Please remember, clinical audit takes minimum of 12 months time because there is a whole lot of process. So you are never going to do for one case the clinical audit. If there are multiple recurrent problems, like you have got multiple ureteric injuries in last 2 months at your for hysterectomies, you need to do an audit. Or you have got a lot of shoulder dystocias, you have to do audit. However, if it is a rarest clinical problems like VVF, okay, you can't only depend on the numbers. VVF, like last 3 months you had 3 VVFs. You still need to do the audit because this is one of the rarest complications which is recurring. Okay guys, hope that's clear. Now, what are the steps of the audit and why you need to know that? Whenever you want to do the audit, because you are trying to understand and you are trying to know the whole process of it. One most important thing is there are 2 types of different audit. One is prospective audit, one is retrospective audit. Prospective is, for example, you have got a lot of wound infections in your post-op ward. So you want to see what is the hand hygiene or hand washing protocol in your unit. If you are choosing prospective from now onwards, the next 6 months, you are going to prospective, going to look into the cases and understand the reasons. That is prospective. Okay, so from June to December, if you are doing that is prospective, but if you want to go back and do, that is retrospective. That is January to June, if you are doing, that is retrospective. June to December, if you are doing, it is prospective. The thing with the problems with these two types of auditors, prospective is whenever we know that people are going to observe us, we are going to follow the protocols which we never did. Correct? That is the problem with prospective. So you are not going to get the complete grasp of the problem. When you come to retrospective, the problem is with the retrospective, you might miss the data, and also you might always, you might have to be worried about two things. One is the Caldecott principle are protecting the confidentiality because you're going through the data. Caldecott principles is very straightforward. If you are looking into particular document for particular reason, you're only going to look at not that, okay, this doctor is doing the hand wash, that doctor is not doing the hand wash. No, it is purely to protect the data and look into what you have been permitted. And also the second thing is missing data. So there are two types of audit. Now let's look into the audit data. When do you do an audit? Whenever there is a problem, like recurring problems, or there is a complaint, okay, that a lot of women had a 3rd-degree tear. That is the problem which you identify and set standard. For example, if you are choosing a cesarean section, you need to know the national standard according to the NICE. So if it is 50%, obviously your data, unit data is much higher than the national data. If not, if there are rare cases like VVF, which you don't have a standard data, you compare with other NHS trust. Now you have identified the problem, you have selected the team who all will be doing, you have set the standard. Definitely there will be a project lead who will take care of the whole of the audit. So, and of course, there are a lot of other people who work for them. Once you have decided, for example, if it is cesarean section, increased incidence of cesarean section. So you are looking into what are the things you are looking at. You are going to look into the indications of cesarean section, for example. So you have formed a team, you are going to collect, and then you are going to look into, if it is retrospective data, I am going to look into the last 6 months data, protecting my Caldecott principles, only looking into the indication, not that I would be least bothered who has done this thing and who has not done it. Okay. From there onwards, I will collect the data and put it in an Excel sheet. And then I look into the trend. During the trend, probably I see for the breach, primary cesarean section is too high. So I need to look into the options, whether people are aware of ECV, trained or ECV, and whether the patients or the women are educated about it. If I see previous cesarean section, repeat section is more, why feedback culture is not there? If I see CTG, variable CTGs are probably the CTGs which are second stage changes which has happened, you need to look into whether proper interpretation is there or not, and also whether you could have done mid-cavity rotational forceps. If too many second stage CS, you need to look into whether people are happy about the operational deliveries or operative vaginal birth or not. Once you have identified all this, now you have to suggest the recommendations. See, audit or any process in the clinical governance is never about only identifying the fault. What next? Then what you do is, there is a clinical governance meeting which happens once in a month. So you are going to discuss with the team what are the implementations you would want to bring in. You will be hard on the issues and soft on people. And you would be telling, okay, you have to be making sure that you send people training for ECB. We have to provide the information leaflets in the outpatient, things like that. And then you have to make sure feedback culture is done. You have to give training for probably operative vaginal birth. You have to see whether the human resource consultants are there or not. Whatever, all this is a hypothetical one. Once you do that, you give a clinical training of 12 months and then you do a re-audit. Once you do a re-audit, your audit loop gets closed. Okay, so I gave a hypothetical example so that you all will be aware of the same. Okay guys, fine. Now there are three things which people are always worried. In your exam, will they ask this? No, but they can ask different steps of an audit, and you must know what are the different steps, and you cannot by heart. If you understand the process, it's easier. That's why I took some time. Now, I've already mentioned audit and research, and service evaluation is something which how the service has been provided is the only one which they look into. As I said, audit is, are we following the best practice? There is a practice. Are we good enough? Are we actually following? Research, what is this best practice is all about? Correct? Against the standard, yes, audit is done. Research, no, that is a new knowledge. Ethical approval, very, very important. Audit doesn't need an ethical approval. Research needs one. Randomization, audit doesn't involve. Research does involve. I think Avinash was speaking about so many different methods. You need to know randomized control trial, double and single, all those things. So remember, audit and research are two different parts of the game. Now, relevant audit topics. If you have seen your GTG, towards the end of your GTG Green Top Guidelines, there are auditable topics. So that is the reason I have given few. And remember, recurring complication across an unit is audit, never a single one standalone event. Okay. Now, I think these are simple questions. Quality improvement process that reviews the care against explicit criteria and implement change, because it is a reviewing process against the standard and implementing the change. Obviously, it has to be audit. Why it is not research? Because research has nothing to do with standardization and implementing the change. Service evaluation doesn't come in. Root cause analysis is a single event where you're going to evaluate. That has got different, even though looks like an audit, but it's a different process and it is done for a single one. I would talk about that in a while. Appraisal doesn't come here. Appraisal is probably how well the doctor is doing. The next one, students compare suture tensile strength against a national standard over 6 months. This is best described as randomized trial, original research, clinical audit, case report, and service evaluation. Again, the answer is quite clear for both. It is clinical audit. Okay, guys. Hope I am good so far. The few questions. First step of the audit, ideally, you have to identify the problem and set the standard. Because without identifying the problem, why you need to do an audit, correct? So rest of the things, this is the first step. Then collecting the data. First step is identifying the problem and then collect the data, compare with the standard, implement change and re-audit. That's how the cycle goes, if you remember. Guys, I hope I am not fast and you are able to follow me. So can you give me some reaction so that I would understand you're all with me. Are you all okay? Perfect. Thank you guys. Thank you so much. Okay. After implementing change, the audit cycle is completed by, of course, once you have implemented the changes, the next thing should be the re-audit. Because what happens, you have done a training for people. See, implementing change, there are only three things. It is more important for the part 3, but I'm still saying, one is you will always look into the human resources, whether they are overwhelmed or how they are doing. That's the first thing, whether you have enough staff or not. The second thing is education and training of the people involved. And the third thing is the protocol updation. Okay. And also resources could be materialistic resources. For example, your CTG machine. Okay, so things like that. So, or implementing change is always about considering the whole system failure and making sure you're not blaming a single person. Okay. Okay. A unit notices recurring ureteric injuries at hysterectomy over the past 12 months and wants to improve practice across the team. So obviously, it would be audit. Reshma says there is no sound. Guys, is there any audio problems? Anusha, is it okay?
No, ma'am,
Am I
it's clear.
audible?
Clear, ma'am. Clear.
Okay, Reshma, you can just log out and log in, darling. Probably you might not be able to hear. Perfect. Thank you. Okay, now when to choose what? Okay, so before we go to the table, let me tell you one thing. For example, let's take an because I want you to understand not only the clinical thing. For example, there's a lift in the hospital. Okay, so in front of the lift, there was a water spillage. Okay, so you were crossing the floor, you identified that. Okay, and by then one of the patient came and fell down. Okay, the patient coming and falling down is an event. Ideally, there shouldn't be a wet floor in the hospital. If it is there, there should be name board. So what you are going to do, you are going to do an incident report. Any incident, lift failure, you will do, because incident report is not only for health, for all the system failures you need to do. So you do an incident report. But if the same person fell down and had a fracture of hip, then you have to do a root cause analysis. Okay, like why the water was there, who identified first, if somebody had seen and why it was not there, why this, what is the probably the team is doing, who is taking care of this, so on and so forth. Okay, so falling down itself doesn't trigger root cause analysis, because guys, remember, this all would take time. For example, if at all so that is about the incident report. You do incident report to every single incident which you thought shouldn't have happened, from health to system wise. If there is a serious injury, you do root cause analysis. Clear? Are we good about this? Okay, now let's assume you have okay, the ectopic was on right side. Okay, but the surgeon was about to clip the left tube because it was edematous. Okay, so meanwhile, you stopped, the scrub nurse said it is not right, it is left. Okay, so it was near event. However, if the surgeon had done this, that becomes never event. Near miss. This was near miss, almost. He was about to clip the tubes. Then you said, no, that you cross-check, the scrub nurse said it was on the opposite side. So that was near miss event. But if the surgeon goes ahead and does this and you realize post-op, that's a never event. Okay, we are going to talk about that in a while. Okay, recurring complication across the unit. By now you know it as clinical audit. Single unexpected adverse event. Okay, then it is an incident report. For example, PPH. It can happen to anybody. So PPH, it has to be reported. Correct? So if it is serious, for example, PPH leading to hysterectomy, you have to do a root cause analysis to understand what happened. Practice appears to have drifted. Deviation in practice, audit to be done. Probably the protocols are not updated. People are not very happy about the thing. Or they are not educated. Or they know, but there are very less people. Measuring outcomes, that's service evaluation. Testing whether a brand new treatment works, it's a research. I mean, you have got a newer drug for diabetes, you have to do it on the patients. That is a research, and of course, that is all dependent on an ethical approval and so on and so forth. Now, I think this is something which you guys are already knowing, so I am moving on. It's a clinical audit where you are going to check the VTE protocol, how well it is doing. You want to check the practice against the standard one. New robotic hysterectomy service has run for a year. Managers want to know its outcomes, complication, rates and cost. Is it audit? Do you guys think it is audit? It is not. Correct? Because they are trying to know this. So this is the difference between audit and the service evaluation. I hope this is clear. Okay. Now, The risk management is a huge umbrella. Risk is any adverse event which has caused harm, which has not caused harm. So under risk management, you get all these things like root cause analysis, incident reporting, risk registrar. The risk registrar mentions how severe the harm was, and I think I have a chart which shows based on the color coding. Incident reporting, as I mentioned, any patient safety event, near missed, logged on to the DATEX system. This is a system. DATEX reporting is what called the incident which you reported. The risk register, of course, you are going to register the risk. There is a register which is maintained where you are going to put all sorts of risk, what happened to the patient. Grading, the risk are there, but whether it is severe or not based on this matrix. For this exam, you need not worry. Just know higher the grade, higher the risk. You are not asked questions on this. So I'm moving on. Just for the covering the things. Somebody with the NS is trying to write on the board, guys. You shouldn't be writing. Anusha, you must actually not allow people to donate because they wouldn't be knowing. Okay. So this is for your information only. Now, a root cause analysis. As I mentioned, there is a problem. For example, let's assume there is a colposcopy report of one patient X. Okay, so it had come as high grade HPV positive, and you had center for probably a follow up. But that letter didn't reach patient X because she had changed her home, but she had informed the colposcopy team. But somewhere this was missed, and she came back with diagnosis of CSFX. So do you want to do audit for this? No. Of course, is there an error? There is an organizational or a logistical error where address was missed. But did the patient do the right thing? She had come, she had done all her job. That is where you do a root cause to figure out why the address, the mapping of the address was missed. Finally, the patient has got a serious harm. That's why you do a root cause analysis. If this patient you figure out and she comes back and there was nothing much harm to the patient, then root cause is not required. You do an incident reporting. How do you do the root cause analysis? Is fishbone analysis, where you consider all the factors, which is there in my next image. I'll show you why. And of course, you will ask 5 whys without the blame culture. And Swiss cheese model is always when multiple errors come into the single hole, that is when the adverse event happens. Fishbone model, this is a fishbone analysis for the root cause analysis which we mentioned, where you have patient factors, you have staff factors, you have an equipment, environment, policy, communication. There could be error in any of this, all of this, which could lead. Generally, the serious harm happens because of this. For example, let's take the post-op patient where the VT prophylaxis was missed. Okay, so she was obese and post-op, you know that there was automatically patient factors, and the staff, people were really probably not, they are aware, but because they have to do the double checking of the high risk medication which they missed. Environment, people know everything, but they were so very busy that they forgot. And what is your high risk medication? Communication protocol, which is in your unit. Escalation protocols. If one was missed, and why the other nurse in the next one didn't do this. Okay. And next, the important thing was the equipment. Equipment could be your VT risk assessment tool, whether that showed whether you could be part of this or not, whether the risk assessment tool had a bleepers or alerters, which is there or not. So finally, when all these factors combine together, there was an adverse event. And when you analyze here, it doesn't end here, guys. Just like your audit, after the root cause analysis, you're going to give the recommendations. Okay, patient had factors you can't help. Environment, provide the necessary staff, educate the people, update the policies, make sure you get a better VT prophylaxis performers or the softwares. install the escalation protocols, make sure they are trained, educated, and then cross-checked again. So this is how you do a root cause analysis even for a single case. That's why this is a process. Even though it is not as big as audit, it's a process. That's the reason you have to be choosing when there is a serious harm, you do a fishbone, because it needs time and energy of the people. Swiss cheese model, as I mentioned, there are multiple holes. This is how the Swiss cheese looks. There are a lot of holes in the Swiss cheese. When they get connected, that's when the event happens. That's why it is called Swiss cheese model. So there was in hazard guidelines, checklist, supervision, team checks. It makes the same sense when the holes line up, the hazard to the harm has happened. So this is for your pictorial representation for you to remember. Again, the difference, I just wanted to make sure because you guys always get worried. Incident reporting, any safety event, you're going to do an incident report. If it is serious event, serious incident or cause serious harm, it goes to root cause analysis. Purpose was to log in, document and flag the event for review. Root cause analysis purpose is to figure out the root cause why this happened and implement and recommend the changes. This would be very brief. Anybody using the DATEX system will put an incident report, but this has a structured multi-factor analysis. Anybody can do the incident report, but for root cause analysis, it's a clinical governance team. What is the output? It is just an entry into the risk system, but root cause analysis is always lessons relearned, and you are going to implement the changes, and again you are going to recheck whether this is done or not. Remember, root cause analysis is for one event, audit is for multiple cases. Am I clear? Is this clear to all of you? Yes. Okay, so now few examples of when to choose what. Wrong dose drug given, no harm, isolated one. You just do incident report. If there was a harm, you go for root cause. Because there was no harm, you would still document in the risk system. Maternal death after delayed recognition of sepsis. There is a serious harm. So obviously, root cause analysis. Near miss, wrong wristband spotted before the procedure, which I mentioned before, like wrong patient, you're going to do a tubectomy, sterilization, but it was wrong. But the scrub nurse mentioned, no, this is not the patient. So that's a near miss. You're still going to do an incident report. Retained swab discovered after delivery. Obviously, you would have done an incident report. It goes to RCA, which is a never an event, which should never happen. Cluster of similar errors pointing to a system flow. Wherever a single case has got a multiple system errors, as we saw Swiss cheese model as well as fishbone model, you go for root cause analysis. So rule of thumb is isolated lapse, incident report without a serious harm, then it's incident report. Serious harm or recurring system failure, it is root cause analysis. Are we clear, guys? Are we all good? Yes, no, not sure? Perfect. Thank you guys for all the continuous reactions which you guys are giving me. Thank you so much. Duty of candor. What is this? Duty of candor is being plain, simple and honest. For example, this is a very common thing which happens when a junior, anybody who does cesarean section, while having an incision on the uterus, there was a superficial scalp laceration at CS. So, there are two things. First and foremost, you can't hide to the parents. You are supposed to go back and talk. You are an ST3, for example, with an ST1. As an ST3 senior, you should accompany your ST1 and explain what happened. That is it. Being simple, plain, honest. Sorry, this happened. We know this shouldn't happen, but this has happened. And we will actually put an incident report and let you know how we can prevent this happening in future. You can't say let the neonatologist figure out and let them do whatever they want. You have to apologize to the patient what it was. And this happened purely because this is what people and public came into the thing. This came out of France's report in 2013, which I'm not talking about because there were a lot of cases which happened. That is when all these rules and regulations comes into the GMC. Okay, so remember The question could come, okay, you send the junior to talk about, no, you are going to a company, so you are going to use the principles of duty of candor. Basically, ideally, as an ideal senior, you're supposed to be going with the junior and let them explain and lead the conversation along with your ST1. Now, single serious patient harm event with an underlying system failure is best investigated by what? Single and harm event. Obviously, you know, it should be the root cause analysis. Which tool maps contributing factors by category? People, process, equipment, environment. You remember? You remember the diagrams which I said too? One was fishbone, the other one is fish cheese. Obviously, you remember that fishbone which matches the components. Okay, I hope I'm clear with this. So the first one, when there is serious harm, you go for root cause, and the second one is obviously the fishbone model. Okay, and ST1, I think this I've already said. ST1 makes small superficial scalp laceration. What is the correct professional response? Obviously, it has to be the duty of candor based on the options given. If it is there, you have to choose where they are actually. You have to be plain and simple to the parents and explain what happened. Now, the consent and the ethics, this is very, very, very important. Mental Capacity Act. Okay, so please remember, when there is consent to be taken, verbal, written, implied, whatever, very important, they have to understand what you're speaking. They have to weigh the pros and cons. They have to come up with a decision with themselves, and they have to communicate. Remember, if somebody has, for all of this, they need to have a capacity. These 4 components are part of capacity. For example, you are counseling a lady for a cesarean section. So once you explain, she has to understand the pros and cons. She has to come into the picture, and probably she would say, no, I want normal delivery. Just because she's not aligned with your management plan, don't say she doesn't have a capacity. She has a capacity, but it's her decision. But again, you are going to tell her the pros and cons of it. Information properly to be provided, and she has to voluntarily agree for whatever it is. Okay, so this is very important. Capacity is understanding, retaining, weigh the pros and cons, communicate the decision. Every adult has a capacity unless proven otherwise. Of course, there are a couple of things like Alzheimer's or dementia, or for CP, Down syndrome, where either they don't have a mental capacity at all, or they had a capacity where they lost. In Alzheimer's, if once they diagnose, at the beginning itself, they are given an opportunity to give an advance directive decision. That, for example, they say, do not resuscitate me. Okay, they would say, now please do not resuscitate whatever happens during my end days. If this is there, because she is giving you her decision in her best of her mental health, this would always stand still because the patient has given in her best of the capacity. Let's assume she has not given this. Then comes legal power of attorney. Legal power of attorney for all these people, somebody with dementia, somebody who had a capacity but they lost over the period. There are 2 things. One is finance and one is the health. Finance, we need not bother. Again, legal power of attorney for health, because this is one of the very famous station for part 3, and they could ask you in part 2 as well. If legal power of attorney could be anybody, next of kin, partner, anybody it could be. Okay, so once the legal power of attorney comes into the picture, okay, so legal power of attorney, for example, let's assume, so I'm just completing, don't worry. Okay, so if okay, I'll come back to you, darling. I saw your doubt. Okay, so legal power of attorney, for example, let's assume there is a mother X and her daughter Y. Okay, so this mother X has an Alzheimer's disease. She doesn't have a capacity to for anything to decide. She has lost her capacity, and her daughter Y is the legal power of attorney. This X comes with a postmenopausal bleeding, and you see that endometrial thickness is 10 millimeter. So you advise her daughter that she has to undergo hysteroscopy. Now this is the legal power of attorney. But she says, I don't want my mother to go through this. But even after explaining her best interest, if the legal power of attorney denies, then you can override this. The two consultants can override this. Okay. So even though if legal power of attorney has been provided, it doesn't mean that they have a final say. It would be always the health professional who can decide in the best interest if the legal power of attorney doesn't decide in her interest. Okay, what I was trying to tell about advance directive or advance decision was, if anybody who has given their decisions way before they have lost their capacity, that would stand still, irrespective of whoever says whatever later on won't be followed. So basically, people who don't have a mental capacity, you first see whether advance directive is there. If that is there, then nothing holds good. If that is not there, then there will be legal power of attorney. Legal power of attorney you discuss, and if they are going in the best interest of the patient, well and good. If not, if urgent, you will go with the two consultants. If it is elective, you go with the court of law. Okay, I hope this is clear. I have repeated thrice. If you still have doubt, you can ask me. Okay. Now this is a very famous slide, very simple one. I think they always ask this. So you can actually go through this, and then probably they ask, what is the person in street, person in village, numerical value. I don't know whether nowadays they have stopped, but this is something which they can ask. I think this I've already mentioned, capacity assessment, understand, retain, weigh, communicate. Okay. All format has got capacity, so respect the decision. Anyone fails, they lack the capacity, so act in their best interest if there are no other advance directive or the legal power of attorney. Okay. Now, the common scenarios which you are tested. Please remember, to call an adult in UK, they should be 18 years. Okay. To sign any legal consent form, they are 18. For contraception and legal age to have sex is 13. Less than 13, even with consensual sex, it is rape. After 13 and less than 18, they can accept any procedure in their best interest, but they cannot refuse any procedure in their best interest. They can accept, but they cannot refuse. 18 and more, they can do whatever they want if they understand. Okay. And for these people, what to do? This fragile age group between 13 to 18. Okay. What to do? So, for example, there is a ectopic which you need to operate, but the girl is not accepting. You have got her mother, biological mother, who is willing, you take her consent. If you have a stepfather and a biological mother, always biological mother is the one whom you will listen to. If both the parents don't agree, there could be a situation where the parents don't agree. Then emergency, it's always the rule. Emergency, two consultants, elective, court order. Okay, we will repeat this again and again, don't worry. Okay. So, before I move to this, I hope all of you know what is Jehovah's Witness. This is a religious group who don't believe in taking blood from outside. They are okay to take their own blood in a single circuit, but they don't want to take from the other person. Of course, there is an exemption where they take a couple of blood products. Now, this Jehovah's Witness signed something called advance directive, where they would say, even if I am dying, I don't want any blood and blood products, what I want, what I don't want, all those things. And this would be signed in front of Jehovah's Witness advocate. But let's assume you have a girl who is 16-year-old. Okay. Even though she is 16-year-old, if in case of emergency, to save her life, even though Jehovah's Witness, you can proceed in her best interest. Once she is 18, if she has signed her advance directive, you cannot proceed. What I mean is, an adult Jehovah's Witness can decide whether they need blood and blood products. Anybody less than 18, You cannot assume, even because what they think is probably the parental pressure or the family pressure is there for them to decide. That is the reason they do not listen to, or probably if it is to save life, they would still proceed. Now, young girl, 15-year-old, torsion, not giving consent. So then you proceed in her best interest because it falls between 13 to 18. Parents Jehovah, young girl, anemia needing blood transfusion. I do agree we need to know how young it is, because the answer is proceed in best interest. I would like to believe probably 16-year-old or whatever, if it is emergency. Let's see a Jehovah Witness who is 16-year-old Jehovah, believes a Jehovah Witness, and her diagnosis was placenta previa. She comes to you at 32 weeks. Okay, and she says, I don't want blood transfusion at any cost. Because she's 32 weeker and she's not bleeding, you can take court order so that you can give the blood transfusion when she comes for a section, because you have a time. Now the same girl, 32 weeks, comes with bleeding, you don't have a time. Consult with another consultant, proceed in the best interest. Clear? Fine. Contraception for a 12-year. You will still give the contraception, report to the police, because less than 13 years, even consensual sex is a rape. Contraception for 15 years. Of course, Fraser and Gillick, you guys know. You check her competency. You say, please inform your parents if you wish to, if you want to, and make sure that you would proceed. But one thing you must understand, that she is not sexually groomed. Like her partner is not like 24 years, 26 years. The age, once it is more than 4 years, not that you send to the social service, you send to the police. No, you understand there is no grooming. There are no costly gifts given to this girl to be sexually abused. Okay. Now, termination of pregnancy, somebody comes to you, a girl comes to you due to rape by teacher. This 100% has to be informed to the police, because the teacher is in a vulnerable position where they can do the same thing to the other girls. Okay. Guys, please make sure to give me a reaction, because there's a very important cases which you can get in the exams. I hope all of you are clear about this. Okay, fine. Perfect. Thank you, guys. Now the Montgomery ruling. See, Montgomery ruling came into the picture because let's assume, Reshma, 4 years difference is whenever you talk to a younger girl and she says that my partner is 6 years elder to me, then you have to make sure that there is no sexual abuse and there is nothing sexual grooming which is happening. Not that more than 4 years you will jump and report to the social service. You will be cautious. That's all. Okay. Fine. Montgomery ruling came into the picture because all the smallest of the risks should be explained. You cannot assume that I am not going to explain this to the patient because this is something which is a smaller risk. This happened when the shoulder dystocia risk shoulder dystocia risk was explained, but Erb's palsy risk was also explained, but it wasn't explained that the cesarean section could completely chop off that risk. That is why, because the doctor didn't explain that risk, probably the patient could think in her own things, because she wants the child to be safe. She could have chosen cesarean section, right? So basically, before Montgomery, there was Bolam principle where the doctor would decide what reasonable disclosure could happen. But after Montgomery ruling, every single risk to be known. That is the reason you guys are asked the consent part of the risk of death, risk of ureteric injury, there is a reason why you guys are tested on those statistics. And when you come to the part 3, when you take a risk consent, you are supposed to be explaining even the smallest of the thing. So basically, you would also explain in Montgomery, these are the risks and these are the things which we could do to avoid. This is extremely important. Okay. So make sure that you would explain all possible risk to the same. Okay. Fine. So this I think I've already explained. I'll still tell you. Adult having a capacity that is 18 and more can consent, yes. Can refuse, yes, even if life-threatening, for example, Jehovah's Witness. Autonomy, patient can decide what she wants. Overriding autonomy is a battery. According to GMC, it is a serious offense and your name could be erased as well. Adult lacking capacity cannot consent, cannot refuse. You can act in the best interest. Okay, court if elective, if at all, if there is an elective or a disputed one, you have a time, you can go for the court order. If not, go for the consulted opinion in case of emergencies. 16 to 17 years, we presume that they have a Gillick competency. You presume that they have a capacity. Refusal can be overridden by a parent or a court in their best interest. We assume that same capacity they have as got adults. That's the reason you don't question them when they accept, but when they refuse, you always question their capacity. Under 16, see the same thing. They cannot refuse necessary treatment. For contraception, you use freezer criteria. Okay, guys. So these are very important. Consent ethics, people get to worry a lot and they tend to mistake a lot. So hope this has given a clarity for the age. I think this is the second time which I am repeating, so I'm sure this would be easier. Now, obstetric specific consent. Woman in labor refusing cesarean section, when you checked, her capacity is perfect. So ideally what happens, you explore her concerns. What happened? Probably she is worried for injuries, or she is worried for the baby, or she is worried for something else. You try exploring her concerns, explain her what could be done. But if she still wants, you respect her choice. Okay? Remember, even if there is a prolonged fetal bradycardia, if the mother refuses, you have nothing to do. You have to document, your consultant has to speak, as unborn fetus has no legal right. And you can't force her for a cesarean section. Okay? Forcefully, you cannot get the cesarean section done for her if she's not willing. Jehovah's Witness adult may refuse blood products even if fatal. A valid advance directive must be honored. Overriding is a battery, which I have mentioned. Refusing a Jehovah's Witness as a child, emergency, proceed in the best interest, elective, obtain the court order. Okay. Now, unexpected intraoperative finding. You were looking for something else popped up. You found a lesion. You can always take a biopsy. Based on, if you're suspecting cancer, you would be very careful because you don't want this cancer to spread. So that's a decision of the surgeon. You can take a mental biopsy, you can take all those peritoneal wash, all that. But remember, for that, you don't need a special consent. If you guys have seen a special consent forms, it always asks you the additional procedures. But this is something which just popped up, so you can leave that. And always, whenever there is an elective surgery, let it be cesarean section, let it be sterilization, you need to give a cooling off period. Generally, what is cooling off period is, you have to give the pros and cons. Patient gives the consent twice. Once in the consent clinic when they come and discuss with you, and again the second one on the day of the surgery. So from the consent clinic to the day of the surgery, there should be a minimum of 6 weeks unless it's emergency. So that is what the cooling off period, where they can decide. On the table, if she says, I don't want this surgery, you're supposed to be cancelling that as well. Okay. So consent should be voluntary. It can be withdrawn anytime. Okay. Let's see a few consent questions again. FGR with reversed end diastolic flow. A capacious woman refuses CS after full consent. After full counseling, she says, no, I don't want. So remember, unborn fetus has no right. So obviously, you have to explore her consent. If even after that she has got, you have to respect her decision and document. You can't say she's psycho because she's not agreeing. No. Court order, you don't have a time. Okay, so you cannot override an adult's decision of having capacity. 15-year-old, hypovolemic shock from an incomplete miscarriage, refuses surgical evacuation. So what is the next step? And she collapses. You were trying to talk to her. She was actually talking and she collapses. So what do? Obviously, according to the medical ethics, you proceed in her best interest. Correct? And this reminds me of one of the question which generally comes. See, as doctors, we also have lot of ethical considerations. For example, let's assume you are somebody who don't believe in terminations. You cannot do terminations and you don't encourage terminations. So, if it is elective, you can always refer the patient. Let's say that somebody who has taken a misoprostol or mifepristone comes with a heavy bleeding, hemodynamically unstable. You know that she went for the termination and that's why this happened. However, you are supposed to be doing a quicker surgical evacuation to save her. So there, your medical ethics would overcome. Clear? Because it is in the best interest of the patient. Is that point clear? As for the patient, how do you take care of our best interest? So for your ethics as well should be changed if it is required for the patient's well-being. Thank you guys. Okay, consent in Montgomery. Doctor used, okay, this you guys need to think. Doctor used personal judgment on how much to disclose and omitted a rare risk. Which principle is this? Before Montgomery, what was there? Bolum. Lab for appendicitis. Consent was there only for appendicectomy. Incidental 3 centimeter ovarian cyst. What do? Cystectomy now, aspirate, remove, do as consented, discuss post-oply, implied consent applies. Ideally, what would you do in this case? Actually, I was looking for an answer for that. I will call her for OP, for cyst. But because that option is not there, you will proceed with appendicectomy. This is a simple cyst. You would call her back to follow-up. Clear? But the same thing, this was twisted gangrenous cyst. You would detort and see, right? You would detort and see, and if it has changed in the color, whatever, you could leave it. Otherwise, you have to proceed with the emergency surgery. I have got this intro findings. One more last slide. I know for the appendicitis, you will always have a confusion. Don't worry. An adult Jehovah's Witness with valid advance directive becomes critically anemic at CS. Her husband asks you to transfer her, but because she has got a valid one, you won't do anything, you won't transfuse because she has not told. It is not that the husband can tell. And also remember, if the patient doesn't know the English language, if you have got somebody who is actually trying to, the relative or the husband is trying to interpret, that is wrong. You have to get a professional interpreter to do this. Clear? Okay, no relative can explain that. How should you obtain a consent from women attending a routine cervical screening? Obviously, verbal consent is more than enough. And also there is a question which always ask, like a medical student, a third year medical student want to observe speculum examination. So what is the consent you need to get? Okay, so you need to get the verbal consent, not the written consent. Okay. Okay, fine. Thank you, Urusa, for all the kind comments. Thank you. We are happy that you are enjoying the sessions. Okay, so again, the few things I have repeated in to and fro. By the end of it, you all should be happy for the consenting. Nobody will have questions. Okay. Somebody who refuses cesarean section has a capacity, respect and document. 15-year-old refuses life-saving evacuation, nothing, you are not going to listen, proceed. Incidental sample ovarian cyst found at laparoscopy, don't worry, do the other procedure and ask her to follow up. Torted pedunculated fibroid, consent for ovarian surgery, detort and see, don't perform myomectomy. Language barrier, elective consent, I think I mentioned this. Hospital interpreter, or there could be people whose language you don't know, right? So then there is something called language lines where you have to just dial a number where the particular language person would appear. That is called language lines. Remember, no family. Cervical screening, verbal consent. Clear, guys? These are all the recall questions, okay? So you can see the references here. Okay, I'm going this faster because we already repeated this. Montgomery in practice. Let's see why you have to explain the smallest of the thing. Assisted vacuum birth. Okay, so probably it is risk of Erb's palsy basically, and also probably forceps if at all, if there is, which can happen, which I think it's Erb's palsy or probably the facial nerve palsy and the tears. VBAC. uterine rupture, suspected macrosomia, wherever relevant, breech or twin birth. Please remember, even though your term breech trial says, but she has to know, understand the after coming head issues. Okay, basically you have to explain all this big and small one. Again, this is the same thing. Adult refusing blood. Please remember, it is not only Jehovah's Witness. Many people don't want to take the blood because of the infections they've got. There could be a lot of reasons. So you have to respect the refusal. Family asks you to transfuse the blood to the unconscious adult. If there is a valid advance directive, you can't proceed. Child, proceed in the best interest. Elective situation, child, parent refuses, seek a court order or a specific issue order. Any Jehovah's Witness patient. Antenatally, if somebody comes with Jehovah's Witness, you have to make sure her anemia is corrected. You have to make sure that she is in touch with intraoperative cell salvage technician. Your trust can have that. You have to make sure you have a Jehovah's Witness consultant, Jehovah's Witness advocate, check her advance directive, ask what she wants, what she doesn't want. She has to wear a Jehovah's Witness red band so that everybody in her care will be available. And of course, in case of PPH, you need to know these are the drugs which you can give. Gillick competence. I think you guys already know. Competence. Gillick competence is a general competency between 13 to 16 where they can say, okay, chalo, 13 to 18 rather. You could specifically under 16, if they have a capacity, if they are able to weigh the pros and cons, they can accept the procedure, they cannot refuse. They cannot refuse. Fraser guidelines, specifically for contraceptive and sexual health advice. Of course, you can tell them, encourage them to tell the parents. If you, for example, you have prescribed OCP, okay, and then you are going to come back and like probably her mother is going to come back and ask, did you prescribe OCP to my kid? At no point of time you are going to tell her, yes, I prescribed. You would only say in the generic terms, if they have a capacity, we are going to give them. Otherwise, this young kid is not going to come back. Okay, you could see Smita has asked me, can you repeat less than 12 years? Basically, contraception less than 13. You can give contraception, but report to the police because less than 13 is a consensual sex is also rape. Okay, guys? Yes, because Smita asked, I gave that. Never event, which should have never happened. Okay, so I think that is something which we all need to be aware. Good Samaritan is somebody where this is I think this is something which always comes in. An FI doctor treating a mid-flight, there is an emergency. So should you be treating? You shouldn't be treating. Ideally, you should be treating on a humanitarian basis. And I think I have a couple of assessment things. Who takes care of, for example, COVID-19 came in. So who took care of whole of the NHS trust? It's usually the clinical protocols. Who follows what happens? It is by the clinical director. Okay. So I think never event as a serious event, basically which should never has happened. Serious incident which has caused significant harm. Sentinel event as probably there was a single event which happened because of a system failure. Near miss, this was prevented from happening, the serious one. You guys all know the suggested list. This is a suggested trigger list. Okay, every unit has got that. Remember, blood loss of more than 1500 ml is the one which would be suggested. Again, WHO checklist. This is a part of your core surgical skills. Know these components. When do you do sign in? When do you do time out? When do you do sign out? Okay. Sign in is before induction of anesthesia. Time out is before incision. Sign out is before leaving to the theatre. Okay. You need to know components. Sometimes they can ask. In part 3, 100% they are going to ask. I think we already know this. Retained surgical swab is classified as which event? Immediately before skin incision, what do you do? Alright, I hope you are all thinking of the answer. The first one is never event. The second one is time out. Okay, hope you are all okay, guys. Shall I move to the next one? Because I think I still have got the assessment part left. Okay, so this is one of the questions which they have asked, I think in July 2024. FI to sustain a needle elastic injury. Basically, while suturing an episiotomy, they get a needle stick injury with an HIV. What is the risk? So it's approximately 3 in 1000 or 0.3%. Okay, so just because this has come up, I just gave you. I think the next part is, we have already discussed this, but you need to know autonomy. The patient has all the right to decide what she wants. As a health professional, you should act in the best interest, and at no point of time you can do harm. So that's where it is like a Jehovah's Witness against her ethics. You cannot do harm by giving her blood transfusion. Justice always being fair and equal to everybody who comes across to you. These are the main pillars of medical ethics. Now, there are a couple of things about the HIV and public interest disclosure you need to know. One of the most important thing, if a pregnant woman comes to you or anybody HIV positive refusing antiretrovirals, you have to respect autonomy, you can leave her. If she refuses, for example, a pregnant woman delivers and immediately she refuses to give ART to the kid, then you have to take a court order, because now the child is an individual human being. You have to proceed in the best interest of the child. She wishes to breastfeed, however, the viral load is too high. You advise against, and probably it means to say that the child would be separated from the mother. That is what you do, because if the mother understands the risk, and probably because of her scenario, she doesn't want the child to miss on, then because it is not like a pregnant woman who is refusing antiretrovirals, right? Because the child is born and it is an individual in its own. Won't disclose HIV status to her partner. See, you're putting somebody else at a risk. So you will encourage to notify her partner. If not, you will notify the partner, so that public interest disclosure to be done. Public interest and law disclosure, where you don't care about the confidentiality, is three such things is, one is HIV, partner at risk, road traffic accidents you would be doing because you cannot deny the identity. Third thing is, in any case of bomb blast or the terrorist activities, you are supposed to be giving them the lawful disclosure. Are we good here, guys? Because this is again one place where you will keep on getting the questions. Are we good? Yes, thank you. Okay, confidentiality and GMC medical good practice, where you need to do. Remember, any child who doesn't want to say to the parent, you can actually need not tell the parent. However, if like she is, for example, if she collapses and you need to inform, then there is no other go, right? And also confidentiality in re-infibulation, like for example, somebody says that you have to sit them back to the way it is, the FGM, then those things you cannot help, you won't be doing. And remember, FGM data, personal data is submitted initially without anonymization to prevent the duplication, because the statistics to be proper. Once you submit an anonymized data, once you submit without anonymization, rest everything would be with anonymization, so that your data could be prevented. Okay, very big question. Rakshit, Jehovah's Witness came in labor, bleeding acutely and unstable, said to have an advanced directive but not seen currently. Can we proceed? Okay, they won't give you questions like this. Either she has an advanced directive, she doesn't have an advanced directive, or she has an advanced directive but right now she says, please proceed with the blood transfusion. She can change her mind anytime. If she says, you can give. If she says, I'm dying, I don't want blood transfusion, you can't give. Hope that's clear, Rakshit. Okay. HIV woman declines antiretroviral therapy. Which principle most directly guides respecting her choice? So this is autonomy. She refused to disclose her HIV status to her risked partner. Obviously, you have to notify the partner. I think the same thing which we discussed before. She can decline because it's for her, but for the baby, once born, she cannot refuse. And for the partner, you cannot put them at risk, so you have to notify the partner. Surrogacy, I am not looking into the lot of things, commissioning couple, that, this, everything. But remember, surrogate mother, if she wishes to terminate, she has all the right. If she wishes to hold the baby, she has all the right. Basically, once she says that she wants to terminate and she has not told unaware, you can only encourage her to tell the commissioning couple. Basically, she retains the autonomy because she is carrying the baby. Okay. few things about the training and the assessment. Guys, you need to know this. ST2 to ST3, the progression pattern MRCOG. Later on ST5 to ST6. Between ST3 to ST5, you have to finish part 2. ST5 to more on, you have to pass part 3 MRCOG. And there are a couple of assessments I think you're all very familiar about, which I would speak about. There is a system of faculty of educators. So the most important person for a trainee would be educational supervisor. Tier 1 is a trainers as educators. Who is this NS who keeps writing? Guys, please don't try writing on the PPT, please. Tier 2 is clinical supervisor. Tier 3 is educational supervisor. Tier 4 is college tutor, training program, PPD, director of medical education. Tier 5 is deputy dean. Okay. Now, why they are important? What is their roles? Few things so that you would be aware. Educational supervisor is the one who is responsible for your formative, summative assessment, signing of the e-portfolio, and they are the ones who confirm your authenticity of the work assessments you have done during the ARCPs. Okay, and they are going to tell you, they are the one who give you personal progression plan, what to do, how you are doing, what your plan, so on and so forth. When you come to the medical director, they are the bridge between medical staff and the board. They give a clinical advice to the board. When you come to the clinical director, they are the ones who oversee the administrative legal aspect of the facilities. That is the reason whenever you have got pandemics, they are the ones who take a major role in deciding, allocating the staffs. Okay, so because they are the ones who have a clinical budget, approval, what protocols, what to be introduced, that is the role of clinical director. Am I clear, guys? Is this 3 roles clear for all of you? Thank you. Now, okay, I think you're all aware, but I'll quickly go through. Remember, formative assessments is right now what I'm doing. I'm trying to ask you, you are trying to reply, you are trying to ask the questions. That's a friendly feedback, which is formative. But on July 1st, when you give your exams, it's a summative where they're going to tell you pass or fail. So that's why all the exams are summative assessments. Okay. Now, there are a lot of workplace-based assessments. One of them is a multi-source feedback. Basically, they are called TON, Team Observation 1, Team Observation 2. Team Observation 1, probably this could be from anybody, like from your staff, from your nurse, from your scrub nurse, your anesthetist, your porter, you have to collect for ARCPs minimum of 10 TON forms, which gets scored. The combined score of that is a TO2 score, which is done by your educational supervisor. Basically, for your yearly appraisal, you need to give 10 team observation forms where your educational supervisor will go through all of that and they would give a TO2 score. This is extremely important so that you are assessed not only for your academics but otherwise as a leader as well. So there are a couple of tools. MEDIC-MRCOG, which is a formative assessment, a clinical encounter, like how we are going to examine the patient, how we are going to counsel. Remember, breaking bad news is MEDIC-MRCOG. Case-based discussion. Let's assume you have managed a postpartum hemorrhage and you are going to discuss the same thing with your educational supervisor tomorrow to understand what you did, what you didn't do, what was the reasoning, decisions. Objective structured assessment of technical skills, which is OSATs. It could be formative, it could be summative. Like you are doing a knot tying, or let's say you are doing an episiotomy. So OSAT's formative is when you are doing, your senior would be telling, no, you have to take the knot this way, you have to do that, you have to do this, right? But when you go for a summative assessments, they are only going to watch how you are doing. Okay, so they would be giving you the competency based on how you do. It is purely for the technical skills. Multi-source feedback, team observation 1 is behavior and team working, where it's a 360 feedback from all of your colleagues. Not non-technical skills, which is extremely important. It is a situational awareness. It's a leadership. It's most important non-technical skills, the softer skills which a doctor must have. So basically, technical decision in theater is OSATs. For example, in theater, you were doing a cesarean section and there was an ureteric injury. You have a situational awareness. You take up the lead. You stop the procedure. Call the consultant. Call the urologist. That is what your leadership skills are, the softer skills. In labor room, you prioritize, you inform, you delegate. That is not technical skills. You reflect on a managed case. That is a case-based discussion. Okay, guys, I hope this is clear. Are we good here? Are we good here? Thank you. And of course, ARCP outcome is only going to come. I'll just show you the difference between outcome 2 and 3. Okay. For example, you have done a CBDs, case-based discussion. When the number of CBDs and mini cakes are sufficient, but the quality or timing or evidence is of concern, then you are given the outcome 2. However, when the number is below that noted in the matrix, that's persistently you are repeating the same thing. For example, you've been called for emergency. Once you miss, that's an outcome 2. When you repeatedly miss, it becomes outcome 3. I'll tell you what are these outcomes in a while. Okay. Okay. This is what I think I had a video. I'm just looking into. Probably that is missed. Okay, fine. Just a minute. Let me see where is that slide of my ARCP. Okay, it's here. Okay, I'll go back. Don't worry. So ARCP outcomes. What is ARCP outcomes? Every trainee is assessed yearly, which is annual review of competency. Based on the whole year of formative, summative assessments, your technical, non-technical, softer skills, 360-degree feedback, you are given outcomes. Outcomes means outcomes decide whether you can move to the next year, whether you have to go back and redo the thing, whether you have passed the exam to move. As I said, you might be super duper training, but you have not passed your part 3. You can't move from ST5 to ST6 at any cost. Okay, so those are the outcomes which you would be asked. The first outcome. So these are the different outcomes you can get. I have an examples, don't worry. Outcome 1. There's the best outcome you can have, satisfactory progress, and you're automatically moved to the next level. If you see outcome 1, done and dusted for that year. Outcome 2. You are really good. You can move to the next year, but you need a targeted training. For example, manual removal of placenta. You did most of the things very well, but manual removal of placenta is something which you couldn't do. Probably you didn't get extra cases. So you are not held because of few things, and it is not going to affect your progression to the next year. That is outcome 2. Outcome 3. As I mentioned, you are super, but you are not passing your exams. So you are not allowed to move from ST5 to ST6 unless you clear your part 3 MRCOG. So you need an additional training and time and extension, because exams comes only twice a year, no? It is same for UK candidates, it's same for the overseas candidates. So that is when you get outcome 3. Outcome 4 is given very, very rarely. They tried all possible things due to various things, not only exams, their behavioral issues, so on and so forth. But because that didn't work, they are released from training unsatisfactory despite extra time. Outcome 5 is they don't know what to comment on, because the evidence what you have provided for the ARCP panel is less. So you are supposed to be providing it again. ARCP 6 is the completed training where you are going to be a consultant. That is when you get ARCP 6 at your 6th year. Am I clear with this? Is this clear? Is this clear, guys? Okay. I have got a video, but I think I'm afraid there is no sound. You can still have a look at just a 2 minutes video. There is no sound, so don't worry. This video should work. Yes. Just a minute, guys. Have you wondered how to remember? ARCPs, here are tips for you to remember. Satisfactory is outcome 1, deficiencies no extension outcome 2, deficiencies extension required 3, release from training 4, improper submission 5, progress to CCT is 6. I think this was a video which I had prepared. Okay. Oh, it's working fine. Okay, now you know the outcomes. Let's see. I think I must be a little more patient for the video to play. There is no sound, guys, don't worry. So this is what I said. Exam, if it is not passed, outcome 3. Tip 2. No formative versus summative assessments. OSATs is the one which is both formative summative. ARCP is summative because it decides whether you move to the next year or not. These are the consent principles. Emergency, proceed with the best interest. Elective, take out order. Biopsy doesn't need any additional things. The 4 pillars of ethics: beneficence, justice, non-malfeasance, autonomy. And I think the last one is common principles. Audit too many cases, root cause single, incident reporting, know the list. Okay guys, I think that was a video which I had prepared, so I thought this was useful. Okay, so let me go back to the previous slide. Okay, I think just to summarize that, ST2 has not passed part 1 MRCOG. Remember, they have to have an extension. There is deficiency academically and they need extension. So, outcome 3. ST2 not passed, so outcome 3. Not passed exams. ST2 good formative OSAS but failed 3 summative OSAS because of limited exposure. For any procedure, ideally before the e-portfolios used to say 3 summative OSAS should be done, or some of the procedure needs 5. But here the problem is, this trainee is very good in doing, let's assume MRP, manual removal of placenta. Formative is very good, but when it comes to summative, this person is failing because he has got a limited exposure. So you give a targeted training but no extension, so outcome 2. This is very important. Substantiative negative comments in TON forms. Okay, team observation forms. Poor TO2 score. Even though you are super academic, super clinician, but the others are not happy, you are not going to the next year. You will have additional training time and extension because this is very important team observation forms. Okay, trainee applying for CCT, all competency complete, outcome 6, proceed to CCT. Are we clear? These are all the repeat recalls which I have put, guys. Is this clear to all of you? Are we good so far? Looks like you guys are more tired than me. Thank you. And few things about the assessments. Poor attitude, difficult to work with colleagues, college tutor informed. What is the assessment which you do when they have got difficult to work with different colleagues? Multi-source feedback or TO informed. Reflective notes on a complex case was there. Your junior colleagues, senior, whoever, it was a complex case. He did a reflective notes but put all the blame onto you. Ideally, it is a no blame culture. So this would be taken up in ARCP. Annual review of competencies, this would be considered. A trainee remove pages from the logbook to keep only the good feedback. Again, this is not an ethical practice. It goes to ARCP. ARCP probity means being honest, ethical, all those things. Which is the formative tool for cognitive psychomotor behavior in a clinical encounter, like you're counseling a patient for breaking bad news. Obviously, it is MEDIC-MRCOG. And summative assessment for a trainee's whole year performance. Of course, it's ARCP, which we discuss the outcomes. Something which assesses the decision making for a technical skill in theatre, straightforward OSAT. Non-technical skills, NOTS. Are we clear? This is one of the EMQ. I have put it in this way. Are we good? All good, guys? Yes, no, not sure. Are we good? Okay. Thank you. Training in difficulty, I don't go through everything. Basically, remember, if somebody is not doing well in the clinical practice, they are doing difficult things, they are doing repeated errors, they could be training in difficulty, who has lost somebody who has gone, who is going through a divorce, or probably health is not well, somebody, they have lost a real, probably closed one, all these things. So basically, this is what indicates a training difficulty. Okay, and this is what you do for a trainee in difficulty. Basically, it has to be, you have to see whether they need an occupational health support as well, so that they could do better. Okay. Divyanka, I think I already said, sweetie. MEDIC-MRCOG is any clinical encounter, counseling, consenting, gynec examination, breaking bad news. Every single thing is MEDIC-MRCOG. Okay. Okay. Few things which I think you guys are always worried for is these repeated ones. See, there's a mixture of scenarios which I have given. Trainee using a cocaine. I have got a slide on alcohol for the trainee and for the consultant, so don't worry about it. Trainee using cocaine because drug abuse. Okay, it is a serious offense. You inform to the educational supervisor, training program director, deanery, and the strong warning would be given. If it repeats, then they are removed from the training. Okay. Women diagnosed with cancer cervix, her screening report of severe dyskeriosis wasn't communicated as she moved her house. You remember I gave this example before, it's a root cause analysis. Because address was changed and this wasn't mentioned from the team. Many cases of ureteric injury in post-hysterectomy audit. Trainee had taken case notes for study purpose home, but it got lost. Incident report, if it is there, definitely you have to choose that. But if you have report to information handling committee, then you have to choose that. That is more specific than incident report. Then, sepsis with retained products in a woman who has undergone surgical termination. It can happen. However, she said no one informed when she has to come for follow-up. That's a serious thing. So that's a serious harm. That's why you have to do a root cause analysis. Okay. Trainee in difficulty. Always educational supervisor is the first point of contact. Okay, guys? Fine. The best formative tool to assess trainee skill in breaking bad news. I think Divyanka, you should be able to answer this. Breaking bad news, everybody knows it's MEDIC-MRCOG. Best tool to assess decision making prioritization under the pressure in labor ward. I'll give you a minute for you guys to read that options. It's quite straightforward again. The first one is MEDIC-MRCOG, the second one is situational awareness, and the leadership, which is NOTS. Okay? Fine. Recurrent abrupt communication is undermining the team. The best objective multi-level evaluation. Again, quite straightforward. Have a look into the options. ST7 has completed all competencies and is finishing training. RCP outcome is, again, if you know this, then you will close your eyes and mark, isn't it? Who is this who is marking the answer? Guys, my goodness. Okay. The first one is multi-source feedback because it's multiple levels, and the next one is outcome 6, as you are all aware. An appraisal trainee, this is training in difficulty. At appraisal, trainee is repeatedly late and smells of alcohol. Colleagues have reported this before. However, he denies drinking. Ideally, you should address the locally first. This trainee you have to address, and ideally you have to give a written warning because it's repeated. It's not the first time, and document in the appraisal notes. This I have got scenarios, don't worry. Trainees found using recreational drugs while on clinical placement with multiple staff concerns about behavior and safety. So this would be a serious one. So fitness to practice and escalate to GMC. This is quite straightforward. I think this we have done. The RCP outcomes. Okay. Fine. Alcohol smells. This is a training difficulty, okay? Alcohol smell, first time denies it. You document informal discussion because the first time you have to document, offer support wherever it is required, and informal discussion. Alcohol smell, repeated, written warning, document an appraisal, and of course you have to address to the educational supervisor and to the trainee as well. Recreational drugs, single concern, first and foremost remove that person from duty, occupational health and local investigation. Intoxicated on duty, reported serious, escalate to GMC. Depressed trainee seeking help, occupational health, a referral. Of course, that is something which anybody can go through and give an off. That rota manager would be able to give an off from the work as well. Okay, consultant event scenarios. That was your trainee. Now consultant. Consultant is intoxicated, smelling of alcohol on duty. Obviously, you have to send the consultant back home and escalate to the clinical and medical director. So somebody will be replacing them for the duty and this has to be escalated. Bullying or undermining. Okay. It should be. See, there are a lot of hierarchies which happens whenever ideally the first thing is to talk to the consultant why they are doing that. If they are not listening, then you can inform to the educational supervisor, you can inform to the dean, TPD, HR, all those things. Then the consultant is repeatedly unavailable. See, remember, on-call consultant, they have to reach in 20 minutes. But this consultant is always unavailable for emergency. Escalate to clinical director. Remember, clinical director is the one who has to run the show of your clinics. Witnessing a serious patient safety concern, you have to whistle blow. Like intentionally during surgery, he has done something probably. That is something which is very, very important. So you have to whistle blow and make sure that it is informed. Okay. Then some scenarios which you have been always asked questions. I think we have done a bit there, but I'll talk about it again because these are all for the recalls. Trainee removes pages from the logbook to keep only good feedback. Fitness to practice, ARCP, because you can't give, honesty is at stake. Trainee fakes vital signs in a chart they never assist. This is a serious probe. So serious thing, investigate, patient safety risk, probably they would be removed as well from the duty or probably understand the concerns and behave. Trainee shares a patient's HIV status in a cafeteria, very common. Okay, very common scenario which you would be asked. There is a confidentiality breach, written warning and document. This you can talk to the person. Trainee blames others in reflective notes for their own error. Discuss at ARCP. Reflective honesty is assessed. Because you can't blame people, right? I was all good, but the other person did. So that is not correct. These are probity or the honesty part of UK scenarios. So basically, honesty and integrity, a core professional attribute for the GMC. Okay, it's not only required to be a good clinician, but all these things are extremely important. Few things, appraisal revalidation, annual appraisals, ARCP. Remember revalidation. Okay, revalidation every 5 years. Consultant or a trainee, you are supposed to prove that you are fit to practice. This all happened because of lot of medical errors which happened before in NHS. That's the reason GMC is very particular. And responsible officer is somebody who makes revalidation recommendation to GMC that okay, this person's license could be renewed. And what is remediation? Basically, it's the formal structured process of a deanery or employer puts in place to help underperforming doctor to get back the required standard. This is a process. For example, somebody not doing well, somebody not performing well. It's not that the system to remove, but it's a structured process in place for the deaneries so that they can support enough and bring the doctor back. This I have given because sometimes in an option, if it is there, you shouldn't be worried. Caldecott principles, I think I've already told. This is to protect the confidentiality of the data. You can't be letting everybody know the data. Caldecott guardian is a person, usually the medical director, who safeguards the patient information. Okay, how many, this is a very common question. How many annual appraisals normally required for 5-year revalidation cycle? If you know your maths, you are done. Look into the options. Senior person responsible for safeguarding the confidentiality of the patient. Just now I said, right? So these are simple, straightforward. The first one is 5 appraisals. The second one is Caldecott guardian. Okay, few things. Never override an adult consent who has a capacity. Always treat recurring, see, you should be making sure that recurring complications should be taken care and done in audit. Even single serious harm should be go for RCA. You cannot hide an error, it has to be duty of candor. Without her consent, you can't actually do any procedure. Confidentiality, Gilliker phrase should be kept in procedure in the place. And definitely, you can't do a procedure where you have not been consented unless it is life-saving, except biopsies. And this is from one of the talks which is important. So I have put this, the commonest reason for litigation. Laparoscopy, internal injury. Hysteroscopy, uterine perforation. Colposcopy, misdiagnosis or inadequate sampling. Hysterectomy, ureteric injury. Urogyne, mesh related problems. These are the statistics one. So you need to know which procedure has got the commonest reason for litigation. Okay, now I have got a lot of things which I am going to repeat. So it would be like rapid fire. So focus and listen. Unborn fetus has no right. So woman holds all the autonomy. Jaw witness may refuse blood even if fatal if she has got an advance directive. Adult I am talking about. They have to give advance directive. However, they can change their mind anytime. 16 to 17 years can consent, can agree. They cannot refuse. Gillick is for treatment, Fraser is for contraception under 16. Gillick competency, Fraser guidelines for contraception. Adult lacking capacity, you can proceed in the best interest. If they have got advance directive, you have to follow. If not, you have to proceed in the best interest. Montgomery, you are going to disclose the rarest of the risk to the patient with reasonable alternatives. Unexpected intra-op finding, biopsy only, unless it is emergency. You can reconsent for elective procedure later on. Cooling off period, as I mentioned, for all elective procedures you should be giving. Duty of candor being plain and honest, which was reported in 2013 Francis report. Unlicensed, okay, if you are doing a drug, giving a drug which is unlicensed, you have to prescribe, you have to explain, prescribe and document. You have to document that you are giving an unlicensed drug. Scrub nurse smelling of alcohol, you can send them off and escalate to the line manager so they can send somebody else because you're going to start the procedure. Professional interpreter should always be used in case of language, never a family is used. Okay, so you have covered almost like 12 SBS here. Recurring ureteric injury audit, screening results not communicated, it becomes root cause analysis. Retained swab is a never event. Of course, you have to do an incident report. Stolen study data with patient data, you have to, incident report you have to do. If you have information handling, go for that. Negligence claim time is 3 years for others, but if they have got, if the child has developed CP, cerebral palsy, then the case could be placed anytime, unlimited time. Pandemic responsibility of a trust would be from the clinical director. Trainee cocaine use, you have to escalate. CBD, ideal for discussing any cases. Departmental teaching ideas comes from the college tutor. 5 appraisals appear in single revalidation cycle because every 5 years it is done. Caldecott guardian safeguards the patient information, which is usually the medical director. Won't tell partner of HIV, you have to disclose. You are going to breach the confidentiality. Okay, Down syndrome, no, she has no capacity, elective laparotomy. Obviously, legal advisor, the court of law. Emergency, you can go in the best interest. Collapse, 15-year-old ruptured ectopic, stranger present, proceed in the best interest. 16-year-old capacitous refusing surgery, mother willing, take the consent of the mother and proceed. Intra-op suspicious mass, consent only for index operation. So biopsy, don't extend. Basically, they are trying to tell whichever the biopsy you can safely take, you can, because it's a suspicious mass. So you must be careful of not, upgrading the stage by taking the biopsy. And there is actually you open for ruptured ectopic, but the ectopic is not seen, the right tube looks edematous. So it's a pregnancy of unknown location. It could be hydrosalpinx. Take swabs and wait. Unless you see like an ectopic, you are not going to proceed unnecessarily to remove because it could be pregnancy of unknown location. This is important, guys. Okay. Retained swab post-delivery. Obviously, it's a never event. Incident report, root cause analysis. Sepsis after stop, no one told me when to return, root cause analysis. ST2 has not passed part 1, RCP outcome 3, applying for CCT, outcome 6. TOP requested by competent under 16, confidentiality. So you have to protect the confidentiality. At the same time, you say, please tell your parents if you can. Okay. FGM. Okay. We are towards the end, guys. Don't get tired. FGM confirmed in a girl under 18. Of course, mandatory report to police within 1 month. FGM declines defibrillation. Baby girl low risk. Which actions are correct? All of the rest of the things HIC data you should be doing. You should understand why she doesn't want defibrillation. At the same time, safeguarding for the girl child. So the GP or the health visitor or the social midwife has to make sure that the child is taken care. Right now, you have to respect her wishes because she has a capacity. Type 3 FGM in labor, urethra not visible. Guys, this is extremely important. You would all know defibrillation with crowning with scissors, lidocaine without adrenaline. Hold on to this because I think I have added explanation why without adrenaline for her. Hysterectomy approach with the largest carbon footprint. Okay, sustainability audit. Okay, WHO labor care guide. I think this is a generic one which I have added. Okay, why lidocaine without adrenaline? Remember, for adrenaline to act, unlike your all other episiotomies in defibrillation, you are working on the vulval tissue, which is scar tissue, which is poor blood supply. So definitely if you use adrenaline, there is a risk of necrosis or a poor wound healing. So if you have an option of lignocaine without adrenaline, please go for that. Am I clear in this? Perfect. These are recall questions, I think. Okay. Fine. Metal mortality, I think you guys know, but just I added direct to the pregnancy. Because of the rupture ectopic, she died. Because she became pregnant, she died, right? So that's a direct death. But she already had risk factors, BMI, LMWH, all that. So it is an indirect maternal death. Pulmonary embolism, she died because of pulmonary embolism. Highest childbirth risk by ethnicity versus Caucasian women. So Black, African or Caribbean has 3 times higher risk. Guys, you have to read the embrace, okay? Because I've already got 100 slides, so I didn't want to add on more. Few rapid fire on... okay. My dear, even if urethra is visible, not visible, see, if you have seen type 3 FGM, it is something you can, first of all, in labor, after 20 weeks, anytime you can do the defibrillation. If they want in labor, you can do at the earliest. But probably the patient came very late, that's why you have to do when you see. Okay. Consent only for hysterectomy only, but left ovary as a suspicious mass. So, take biopsy without consent based on Safa. Please stop writing, my dear. Please. Anusha, you have to stop these people the permission to write, dear. Otherwise, half of my time goes with this. Guys, don't touch the screen. Please wait. Okay. Biopsy could be, need not be of the mass. You should make sure. Okay. You should make sure that you are not going to extend or upgrade the cancer, but biopsy doesn't need consent is what I said. Probably omental biopsy or the peritoneal wash. Open for twisted right ovarian cyst. It was diagnosed as twisted ovarian cyst, but normal ovary found inflamed appendix. Consent only for cystectomy and oophorectomy. Ideally, ovary you don't do anything. You call for the surgeon and generally they would go ahead and remove if it's inflamed appendix. Otherwise, they are going to come back with the peritonitis. Okay, so you are going to call the surgeon, they are going to remove. Open for suspected appendicitis or a simple ovarian cyst. You are called, you go and see simple, please ask them to come and follow up in your OPD. Open for suspected appendicitis or dermoid ovarian cyst. Again, nothing doing, you close and ask them to come back later. Okay, patient consented for laparoscopic hysterectomy with past history of dermoid cyst removal. Intra-op surgeons finds dermoid cyst adherent to the pelvic wall in the ovary file. Basically, they have given only consent for hysterectomy. So, please do only hysterectomy. Even though you can see dermoid cyst, you can't do much unless she has consented. Open for appendicitis laparoscopically but there is torted ischemic right fallopian tube with watery discharge. That means it's gangrenous and almost gone. You go ahead with, in the best interest, laparoscopic removal of the tube. Patient with labor pain and transverse line needs surgery. Little English, she and her cousin was translating to them and said she don't want CS. Means patient's cousin is translating and he is telling that he doesn't want CS. So please get the professional interpreter. Don't believe in the relatives. Patient with abnormal CTG refuses CS, doesn't want cutinotomy. She has a past history of psychosis, now diagnosed as mania. Very important. We know that she doesn't have a capacity. So autonomy gets ruled out here. You have to see when before she lost her this one, now she has mania, whether she is given advanced directive. If not, emergency, you have to proceed because this is abnormal CTG. You proceed with a 2 consultant opinion. If it is normal CTG, you can, if you have time before she comes into the labor, you can take the court order. Clear, guys? Can I get any reaction? Because I know these scenarios you would be a little worried. Are we clear? Fine. That finishes the clinical governance part. So guys, what I have tried doing here is to make sure that, like I have covered most of it, all the different aspects of clinical governance. I had 100+ slides just to help all of you to cover things. But there could be a lot of newer things which they could ask. You have to just use your concepts to answer them. Okay, so I must thank all of you for being with us for the last 10 days, and you all have been so patient. I know you all will be in the duties. You're all doing a fantastic job being with us and helping us to, motivating us, giving the fantastic feedbacks. I'm going through the feedback. They're all really, really great and kind. Thank you so much. I hope these sessions would help you guys to clear these exams. The purpose is help you to clear your exams. And I'm getting a lot of queries for the 2 days, 5 days crash courses. Guys, you can get in touch with the team. I think 14, they have got 1 day EMQ and 2 days and 5 days. So many things are there. Okay. So Rubina, you can actually, I'm sure you must be in any of the short courses. If not, you can ask the team. They would be happy to help. So you can be in touch with me. And so I hope all of you enjoyed as much as we enjoyed this process. This wasn't easy, but this was worth all the efforts. After I saw your feedback, this was worth all the efforts because lots of sleepless nights to create these PowerPoints, and it is not easy to put everything in one slide. I think I could do purely to help all of you. I want all of you to be successful. Hope these 10 days have helped you to revise and give an orientation. Okay, so thank you so much, guys. Don't forget to drop the feedback, and may success be yours. You will always be in our prayers. Loads and loads of gratitude. And remember, these exams are very much doable and you will be able to pass very easily. That's the confidence you need to carry. Okay, all the best, and thank you so much, guys. May success be yours. God bless and good night. Thank you, everyone. Thank you.